misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat earth in its place.
Welcome everybody to Tuesday night on a Thursday. I'm your host, MCToon. We are going to a crazy Discord server, the one run by QOP. And if you don't know QOP, well, I had a debate with him a while ago, and he's a goofy guy. I like him though. He's kind of fun, and he's got a Discord server, and he's been putting in the work and really been doing a lot on the Discord server. Here it is. I linked it in the description. He's also got a YouTube channel. I'll get that in the description in a bit. But we're gonna join in here in just a second. Here, let me pop in. There we go. And now we're in.
Light down, allowing you to see something higher.
Hey, hold on.
It's exactly what I'm showing right now.
Yeah, 1 second. I gotta dig through some of my footage here right quick. That's the wrong one. Is it on this one?
Lanolin made a movie as Icy Spins.
Hey, look,
Interesting.
Tell me, is upward refraction happening on a frozen lake today, or is downward refraction happening on an upward lake today?
Oh, it's going to bend light down, allowing you to
typically
see
down.
Higher, yes.
No. He said it's always down on a frozen lake.
Yeah, it's going to
typically anything that other than the bunk spider. Yeah, typically.
He's saying that it's just always going to be downward on a frozen
cold air
lake.
more dense? Is cold air more dense?
It depends.
My mic is hot.
It actually depends. It actually depends because you're saying air. So if you subtract,
Icy Spin, what do you mean my mic is hot?
If you pretend that everything is dry in the environment, then cold air would always be more dense.
More
than warm
mirages.
Air. Okay, so what I'm saying is we're seeing.
Lanolin, don't explain everything to them.
I don't think he understands it.
All I'm saying is these guys don't know what they're talking about, and they're invoking.
Thank you.
And this is why I said it's kind of pointless arguing about refraction, because
you'll say no.
We can argue about this all day. So do you have anything? Do you have anything?
He's gonna say no. Do you have anything other than your evidence? Yeah.
Yeah. Because it's stupid. Like, we're gonna argue. I think refraction does this, and we think refraction does this. So we're not gonna go anywhere. We're not gonna
Shut up, Wesley.
No,
so
I mean the facts of the
is there
matter
anything you have? Okay, other than looking at the horizon.
The horizon is the most significant because you guys are claiming that it proves somehow curvature, and it doesn't.
It's only a piece, a piece of the puzzle.
Can you stop interrupting?
A piece of the evidence.
It is a piece of irreducible complexity. It is the piece of irreducible complexity, meaning if you guys don't have curvature, then it doesn't matter what
we do have curvature though. We do.
Don't though.
Oh yeah, we got lots of curvature. We got curvature coming out our ears.
You have optics that fail.
You got any measurements?
Every single time.
Yeah, we got plenty of measurements.
Oh yeah, we got measurements too.
I got measurements that are better than your measurements because I have
two measurements.
Yeah. Let's go look at here. Let me just give you.
Show us your best measurement, and we'll show us ours.
It's all yours. It's all yours, Toon. Your show.
I'll give you.
All right.
I'll give you literally the full data sheet. Here we go. Let me get to it.
Oh, look at that! Look at that curve, Black Sabbath there. Look at that, nice curve, Black Sabbath. Now, Apocryphon, this one's interesting. This one here, I think, is done with a 360 camera like this. And that's exactly what you'd expect from a camera like that.
There we go. If you guys want a data sheet where people actually did the measurements, measured our lapse rate and everything, there you go.
Yeah.
Yeah.
Where'd you put it?
I mean,
where'd you put it?
I'm stream sharing right now.
Live.
I mean, there you go. We did the calculus. We gave you
read it and weep.
I mean, I gave you my dry term and my wet term. We have literally exact measurement.
Wait, you did the calculus. I don't see any calculus there.
It's because
what do you need a formula?
No, I mean you just you said you did the calculus. I don't see any calculus.
I'm not saying it in the data.
Calculus doesn't require a formula.
Look, I am giving you.
Oh my gosh, Sin Cleanser, you are wasted. Holy cow! Oh my god.
We don't need math to prove anything.
Can you?
Here's the other thing.
Can you send me the
laser from the side?
Can you send me the source of the source of this so I can have a look at it instead of just on your stream?
The source. I am the source. You're talking to the guy who did it.
I am the source. Oh my gosh, are you the citation?
That's a Xanac. That's Xanac.
That's not Xanac.
Xanac. Yes.
That's Arwen. That's Arwen.
No, Xanac is the first to say I am the citation. Get
is he?
Lore right. Yeah.
There's my video in the chat. All my raw footage for these observations, all the raw recordings at least, will be uploaded not only to a download site where people can stream it, so it'll be the most comprehensive refraction study that will be available on the internet yet.
No, it won't. Oh my gosh.
Damn.
On YouTube.
You've not done your background research, have you? Hold on a second. Listen to this.
Available to the public.
You get the fuck out of here, dipshit.
Be available to the public. So yeah,
let the public see.
Oh my gosh, I know. That's right. I love the confidence. It's very top, and it's left. It's very left. Very nice.
That's very right. Very correct. Very true.
We could just say elite.
All right. All right. So where can I peruse this on my own time?
I said yes. All my raw footage will be uploaded within probably the next 2 to 3 months. Might even be within the next whatever. But I did put out my movie, so if you want to watch the movie, I posted it in the side chat.
All right.
In the side. Well done. We need more of that.
Yeah. Thanks, Icy Spin. Thanks, Spin.
And I recognize that when I upload this raw footage,
thanks, Icy Spin, for the flat Earth proof.
There'll be a lot of people who take my raw footage and they'll run with it saying flat earth proves globe because they'll take things out of context. They won't look at the measurements.
Well, that's a common thing that happens pretty much 100% of the time.
The thing is, I'd rather be transparent. And
Globers
honest.
Do take flat earth proofs. Yeah.
Like I'm not just going to upload all the stuff that looks to appear to support my side, right? Because you could just cherry pick observations that make it look like that what you're doing is telling the truth to the audience. Like, oh, look, you can always see geometric curve. When in reality, I'm going to show observations where light's bending down, and I get compressed like an Oompa Loompa, and I don't disappear bottom up. I actually just disappear all at once.
All at once?
Oh, yeah. Let me show you this. Hey.
Crazy stuff.
Yeah, let me show you. Let me show you what goes on here. All right. This is fantastic. I love showing this.
Buckle up.
I got the buckle going.
All right. Here we go.
Put on your plastic helmet.
Let me show you what happens here. So, we made a sweet movie, blah, 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 whatever. Do a lot of special effects, fun stuff. I do make movies. I'm a very skilled movie maker. All right, so we did this thing.
Not to honk your own horn.
Right. Well, no, I'm just trying to put
He's a legend.
You make movies, and I
Spielberg of Rumble.
I thank Jesus for giving me the skills.
Thank you, Jesus Christ.
Yeah. All right, so I ride at a maximum of 1.9 miles from the camera here. The implied geometric curvature, if there is curvature, is just 2.4 feet, and there should be no blockage of me 1.9 miles away. All right.
I'm a stupid flat earther, right? And I'm just a loser.
This is the observation, okay, where I'm showing how I slightly did a color correction because the camera white balance wasn't set correctly. I did a slight color correction to the footage. So it was a little bit more pleasant to look at. Okay. And if we speed through
this is pretty great.
If we speed through it a little bit, let me lose this lag because I'm viewing it from a hard drive here. The reason why I know that light's being bent down is we actually just passed a bunch of snow machine tracks that I left earlier, and they appear at the same height as my head. So I can see that the surface of the lake is appearing higher than my head. I'll go back and show you in a little bit. But here I am. Compressing, we're zooming out, following me out. I'm compressing, I keep compressing more. I'm becoming like this squished object. Okay, more and more and more and more. I freeze here because I'm trying to show people what's happening to this mountain in the background that we pass by pretty much every single day. I'll show you what that looks like, and I'm talking about how we have to account for humidity when we make observations. Okay, and then here we go. Here's that same mountain, okay, on a different day where I can see much further, okay. And then this is on a day where light's being bent down. It's being raised up quite a bit. Here's that day again. Okay, same mountain. If you pay attention to this up here, you'll see the ridge line is at the exact same spot during these wipes, okay? It's at the exact same spot during these. Okay, here's a day I could see really far again. And then back to the day that light is clearly being bent down. Okay, making it appear like the horizon is lifted. Okay, and then we continue. And I'm getting squished, I'm getting squished, I'm getting squished. And this is going to carry on until I eventually disappear at 1.9 miles.
They don't want to see this. This is offensive.
Well, what I'm showing is that downward refraction is an incredibly destructive force. In fact, any refraction is destructive. The best way to see the furthest would be just to see straight lines. However, that's not what we witness.
We don't see that. Yeah.
Yeah, and not even just at the horizon, but
so look at. Can you pause for a second? Can you pause right there?
Right here.
So yeah, just just pause. So yeah, all right, Sin Cleanser. Hold on a second. You got to give him a chance. The in the background there, the line between the snow and the mountain, right?
Mm-hmm.
Right. That's choppy all up and down, not because it's waves on water, but because it's. Right, this is snow, so it's not actually moving up and down like that, right?
Yes, we know this. We know that this is a refractive quality wear. Now, I've already shown, and I'll go back to it. I'll show you a hard, crisp horizon where I am beyond how far I should see. Okay, 6 miles, by the way. I'm 6 miles away. I've got an inferior mirage happening on the ground. Okay, and it's a crisp horizon.
So what was happening? What were the conditions on this day?
So on this day, we do not. On this day, have the measurements of the gradient, because this was actually a test. We were actually just trying to see how well this would work, how well he'd be able to track me. So we don't have the temperature readings for this day. This is just on the mill. We're getting ready to go to bed, but we do know that
is this light. Is this late in the day?
Seems honest. It looks like an honest measurement.
Hold on, Sin Cleanser, just a second. Late in the day.
I wanted to show it in black and white. 1 second. I want to show you what it happens at the end, because I want to show you how I disappear all at once, not from the bottom up, but I just vanish. Okay, so you can actually see in the black and white very clearly my snow machine tracks. Here, let me zoom.
Good shit.
You can see my snow machine tracks trailing behind me as I go out, and they extend all the way to the left. And then
that's awesome.
I'm just going, and I'm going to disappear, me, tracks, and everything right there. I'm gone. Tracks go right up until I'm gone.
Earth curve.
There, I'm gone. Now that's downward bending of light. That's a very destructive force we're seeing right there. All right. Now that's downward bending of light. That's a very destructive force we're seeing right there.
Who's looping? Who's looping the audio? Jimmy?
I don't know. I think
it's Jimmy Madison. It looks like
Jimmy has a hot mic.
It looks pretty flat. It looks pretty flat to me.
Okay, so that was, you said that was just before you went to bed. So was that at night?
That was right before we wrapped up for the day, because we had just gotten out there. We had set up the station. I believe this might. Well, I can maybe go check. I mean, I might be wrong on this because my memory.
Yeah, the file name was condensation dew point.
Condensation dew point.
That was the name of the file.
Yeah, it's because we know that for light to be bending down on that day, that the surface, either one, has to be cold, super cold, so that the moisture trying to escape the surface via sublimation is not actually lifting up away from the surface. It's being drawn towards the surface because it's
the moisture. What's the moisture due to refraction?
Well, so because you have a surface, right, okay, that has moisture content in it, almost anywhere you go, I mean, it's pretty hard to escape moisture, even in a desert. There's usually some humidity in the air. Because
I asked you, what does humidity do to refraction?
Well, it causes an upward thrust. Okay.
Refraction. Wait. Wait. Humidity causes an upward thrust?
Right, because you have on the surface of the lake, you have water vapors leaving the surface. Now, water vapor is a molecular weight, 62% of that of air. So it is almost a third. It's actually a little more than a third less dense than air. And so you have a less dense material underneath a more dense material. This is called sublimation. We see it on frozen lakes all the time. It's a very well-known phenomenon. It's called the Fry's principle. All right, and then there's the Archimedes principle, which is if you have something which is buoyant underneath something which is more dense, then it will lift up through it. And it's a measurable kinetic thrust that we can measure with the humidity. Now, there's another thing about humidity which influences refractions, and that is the smoothing
You are destroying him.
This is the smoothing effect on the temperature lapse rate, because humidity will carry the temperature of the surface upward with it, okay? So if the surface, let's say, is warmer, let's say it's 34 degrees, or, well, in this case, let's say it's a frozen lake. So let's say the temperature
to be below
is 24 degrees, okay, and the air temperature is 15 degrees, then the vapors leaving the surface are 24 degrees upon initially leaving the surface. So they have a heating effect that falls off as they lose their temperature as they rise up through the colder air. So not only do you have a buoyant force pushing up on the air, causing a lower density zone directly at the surface, but you now have the temperature, the temperature being smoothed out, meaning you can't have large fluctuations in your temperature lapse rate anymore because you have vapors which are directly stroking it out. It's like taking a paintbrush and smoothing it through. I mean, it's the same idea as like dumping a bottle of perfume on the floor. The reason why you smell the vapors is because they're rising up through the more dense air.
I'm a stupid flat earther, right? Yeah. And I'm just a loser.
No, wasted has nothing. Wasted has nothing to do with
waxing. Humans eating feces.
So there's a lot to do. Humidity has a ton to do with
look. Anybody who's got sound effects abilities needs to shut the fuck up.
Yeah, it's really hard for me to.
I'm a stupid flat earther.
They're doing it
and I'm just a
loser.
I think people are just getting tired of the book you're reading. Maybe that's it.
It's not a book. There's no book you can read this in. Actually, if I go to the original source document,
maybe you could see the sarcasm. You're not even seeing that. You just won't shut the hell up and let somebody else talk. Is what maybe is people complaining about here with the sound effects.
They asked me a question.
The question was, what does refraction do, or what does humidity do to refraction? And the answer is it reduces it. That's all you. It reduces it. 3 words is all you needed to say.
Listen, it changes where density is positioned, is what it does. Okay, if you take just water vapor and you just put it into a hydrostatic environment, humidity does very little. It will reduce.
Just never stops.
Well, because I'm giving you a very clear understanding of something that you don't
doesn't ever stop talking.
What do you say we hand it off to Toon for a minute, and then y'all can go back and forth?
Yeah. Right, cool. So I set up a time to come in here to have an open debate here, just to chat with everybody, see what everybody had. Everybody, not just one person. So, and Sin Cleanser, he specifically went out and bought some hooch so that he could be sloshed wasted for this time, because that's how he rolls. So I wanted to say hi to everybody and have an opportunity for people to get in here. A couple people had mentioned that they're blocked QOP, and maybe you could unblock them. I think Brenda was one. Anybody else? Anybody? Brenda.
So Brenda, the first day we streamed, Brenda said she was gonna report somebody because someone said something that offended her. So I'm not gonna have someone in my VC that's reporting us.
Well, people can still see you on YouTube now that you're streaming there. So. I don't know. When you're doing stuff in public, you got to be careful. Just tell you that. All right. Well,
what I believe is that
a terms of service violation. Terms of service violation would be the challenge. But it's your server. I can give you the message. So anybody else, let me know. I can convey. But all right. Sin Cleanser, what's new with you?
I don't think he's here.
Did he leave? Man, he bought all that booze just to leave? Oh, he'll be back. All right, queue up. Anybody else kicking around here?
As drunk as Sinklins. I
No,
think we can unmute Demok.
it.
I think Demok is usually pretty drunk.
I think he just has pure vodka flowing through his veins. Demok in small quantities is interesting. Maybe we can hear what new derp he has today.
Do you want to go back and forth with Lanolin at all? Yeah.
It'd be interesting. I don't know if he's capable of that, but it'd be interesting.
As long as you have a certain amount of time to speak, and then I get to reply in a certain amount of time, or I get to bring up my own points, or just use it to... I don't want that way we don't just fight each other back and forth on question to question. It's like you can say what you know about refraction, and I'll say what I know about refraction, and then the audience can divvy it up within themselves, like debate it between them within themselves.
Let's just spend half an hour talking about meta.
Is there a way to have a back and forth debate about something other than refraction, though?
Oh, that'd be interesting.
You guys have standard refraction all calculated, and you don't want to deal with any changing atmospheric conditions?
No, that's not us.
No, you guys only
semantical.
I like speaking about refractions only because it is the point that I believe is often ran away from and is avoided. I think it is one of the most intense and verifiable pieces of proof where you don't have to make so many assumptions about the world, where you can go out and you can measure these things without having to assume large things. Like we can assume that if we see a shadow right there, assumption, we see a shadow on the moon, that it is the Earth's shadow, right? Well, is it a shadow in the first place? Like there's a lot of things that we...
What else would it be?
Oh my gosh, of course it's a shadow.
Exactly. What else would it be? You could recreate this observation in your kitchen.
Well, again, I'm not going to debate these things because I believe they take too many assumptions, whereas something at the Earth that's tangible, that a man can actually walk between the distances and do the measurements, is something that we should focus on, like what the layman can do, because
that's a good idea.
Has power over his own destiny.
I have, I'm going next week to Pensacola Beach, have a meetup one of the days there based on what day is the good weather. And we'll be doing a couple things. One, we'll be seeing if the sun's angular width stays full width as it sets. That's specifically by a flat earther that challenged me to live stream the sunset. His name is Damascus Steel, and he has about 20 other sock accounts. Also, I'm going to use a laser rangefinder that I have and measure the distance between 2 points as pretty much as distant as we can be certain that we're getting a good solid reading. I have retro reflectors to bring. And then I'm going to use the globe to determine, we're going to walk that, right? We're going to walk from one side to the other. We're going to use the globe to predict the distance between the 2 points, and then use the flat earth to predict the distance between the 2 points. Exactly what you were suggesting there. I think that's a good idea. You know, something that the normal guy can do. I got this laser rangefinder. It's for hunting. Why would the distance
be different? Why would the different distance be different?
Because the geometry of the surface of the Earth makes a dramatic difference on the distances between points.
You're assuming they calculate that distance and they incorporate the sphericity of the Earth.
I'm not assuming. I will do that by hand myself with my own formula. Actually, it's not my own formula. I use the formula that Flat Earth Dave uses in his app to compute distances between points on the surface of the globe. It's kind of funny. Anyway, I'll use Dave's distance, his version of the Haversine, which is the same as everybody else's version. But I use the source code.
You're doing math, and you're basically deducing, assuming the GPS is correct, assuming the distance that you're told, and then you're just doing math.
No, the distance. It's not. Hold on. It's not the distance that I'm told. It's the distance that I personally measured with the laser rangefinder in my own hand. Then I'm using.
You're not measuring the Earth curve, though.
No, this isn't an Earth curve measurement. This is a distance across the surface of the Earth measurement.
You're using it based on two things. Maybe one is the distance you're measuring is correct.
Exactly. Exactly. And this is fantastic. Well, if there's a different coordinate system that any flat earthers want to use, they're welcome to do it. and they could come there and use whatever coordinate system they want. I will document everything so they can look at it and say, well, here from here to here, this is the flat Earth coordinate system that was used, and here's the way to compute the distance between those 2 points on flat Earth. But we all know that everybody's going to drive there using the GPS on their phone. So everybody's already assumed that GPS is correct just to get there.
Well, the GPS isn't one uniform model. It constantly corrects over and over, so it's not like one map.
I don't know what you're talking about. Like, a GPS isn't a map. It's just a way to identify your coordinate system. Your coordinates within a coordinate system. What's that?
You guys model it on a sphere, but it's actually not a uniform map. There's like
it's not a map
per second or something.
QOP, it's not a map at all. It's not a map at all.
Exactly.
GPS just
it can be spoofed, right?
Yeah, but not very easily. Like you'd know it. Like they'd jump all around, and it would, you'd say, well, here, where am I? And then you'd compare it to where you were, a minute ago or 10 minutes ago, or where you have a good idea of where the coordinates are for where you're at, and it wouldn't be there. So you'd know if it was spoofed. And everybody driving in their cars using GPS would suddenly, their cars would be confused about where they are, and they'd get lost and everything. And it'd be an absolute mess. Everybody would know instantly. Yeah, you'd drive into lakes like in The Office. Nobody would be confused about whether or not it's being spoofed. So, and the cool thing about GPS is it's just coordinates. You can get the same coordinates using multiple different methods and get the same answer. So in fact, I've done that myself. So they all agree. I've used in the Southern Hemisphere, I've used GPS to determine the direction of south. It worked 100%. And I know this because the next day at local solar noon, the sun was pointing toward on the same exact line that I drew with the GPS. So the GPS matched nature. An amazing confirmation of the accuracy of GPS.
I've seen Hervé Rabani in his truck. He was driving a route, and he was recording out his window the curves and the turns which he had to traverse on his route. And then he was also aiming down at his GPS. And he was noticing that the GPS had less aggressive turns than what he was experiencing. However, it would update his position to accommodate these turns, meaning like he's in the turn, he's in the curve, but it would speed up, kind of slow down depending on where he was, meaning like it's putting you in the position on the map, which would be kind of in accordance to where you would think you were on the ground. But if you're just looking out ahead of you, it's like this turn is far more aggressive than what my map appears to be showing.
Yeah, anybody that's used a GPS driving app will recognize this, that the driving app will figure that you're still on the road, even though you may not be on the road. Like if you take an off-ramp and the driving directions is saying that you should not go on the off-ramp, it will assume for a bit that you're still on the regular road, basically using dead reckoning type mechanisms. And then once it updates the GPS, it'll say, oh, no, you're not there. You're over in this other lane. Looks like you took a turn. That's just the GPS app, the map app, Google Maps or whatever you're using, trying to make some intelligent decisions about where you are. That's not what I'll use. I'll use the actual, have an app on the phone that's just a raw GPS app, and it just gives you the numbers, and it increases accuracy the longer you keep still. So that's the one I'll be using to get my position.
So this wasn't about, my statement wasn't about predictive where you're at. It was just a observation about the aggressiveness of maps the aggressiveness of a turn as presented on a map, as opposed to what you actually look out and see. That's all I was saying, was that the map didn't quite match what one would optically see with their eyes. Is what I was
Doesn't matter. I won't be using that app.
And
I won't be moving
with maps in general. So
yeah, I won't be using it.
The
Doesn't
map
matter.
won't change. The map won't change based on your. Well, I'm saying like this seems to be intrinsic across any map projection, because it's a Google Earth map projection that's being used.
It's not the map projection though. It's the map app that when you're driving, it's doing some Dead Reckoning type things to figure out where you are and saying, well, you're currently on road 123. Road 123 does this turn, this turn, this turn, and that's the route that we have said that they should take to get to their destination. And so we're going to assume, lacking other data, that they're actually on this road. This isn't. I don't know why this is confusing.
It's not. I just recognize we're actually talking about two different things, and I keep trying to tell you what I'm talking about.
Yeah,
that's okay.
I don't care. I won't be using a map app. I'll just be using a. Here it is. GPS coordinates is the name of the app. There it is.
Some other thing that was to be mentioned was you're using laser ranging, which is a light-based, distance calculator. Light being radio, just anything that's of a wavelength, which has to travel through an optical medium.
Yeah.
Just an interesting thing that you might want to consider accounting for. I just showed people like what light does when it's moving across any refractive medium.
Yeah, but how does that affect the speed that the light travels through it? That is within the margin of error of the measurement we're taking.
As you're assuming a speed?
No, light has a speed. It's not assumed. It's been measured.
They do treat in other parts of physics that light is actually being drawn into things and not being emitted out of things.
But we're not talking about other parts of physics. I'm talking about a laser rangefinder. And it's accurate to...
Which one is it?
It's accurate to half a meter, or half a yard. So, right? We're not talking about millimeters here. Right, we're talking about 1.5 feet of that's our margin of error.
Within a certain range.
What do you mean in a certain range?
Meaning it's only going to be accurate in like your near field, and then as you get further and further out, the error will get exponentially greater.
I don't think you mean exponentially.
I do mean exponentially, because it's light and it's going to incur more refractions upon the path, meaning like you could actually end up not even hitting your target if you're aiming far enough.
Oh my gosh, it's not exponentially. It's not exponentially.
Does light bend in
it's not even
form?
Oh my gosh, we're talking about the distance. The distance measurement. It's the arc measurement versus the chord measurement. The arc versus chord difference does not increase in an exponential relationship. Holy cow!
I'm just posing it for you.
You just chuck out exponential because you think it sounds fancy. It's not correct.
No. I'm trying to hear what you're trying to say. I want to know what your stance on light and your laser ranger and the accuracy of your instrument. I just wanted to hear it. Heard it?
Yeah. It's all those things that you think might be an issue will be significantly under the margin of error of the instrument I'm using.
That's all light. I'm just pointing it out.
Yeah, nobody is needing to hear that lasers are light. Everybody knows that, buddy.
Well, a lot of people don't know that radio is light too. They think that it's something magnetic or whatever, and it's like, no, radio is actually light. I mean, you're presumably using
engineers don't call radio light. Generally, when engineers use the term light, they're speaking mostly about visible light plus ultraviolet and infrared. So they don't generally say that, oh, well, the radio waves that are 2 gigahertz are light. Don't say that. Right. So the umbrella term is the electromagnetic spectrum. Then within that, a narrow range is generally called optical or visible light. And when you use the word light, that's usually what people refer to. But you can, if you really want to, say, well, okay, everything is photons and therefore everything is light. But that's really the other way around. Yeah, it is photons.
I would say it's photons. Yeah,
I'm saying it's photons. Yeah. It is photons.
You're saying it.
Yes, it is photons. Yes, 100%.
According to you, yeah.
No, not according to me.
100%.
I'm not the citation on this. Arwin is the citation on this, right?
I'm saying I can find a bunch of citations.
Arwin is always the citation. Listen.
And he said, yeah, I am the citation. Get the fuck out of here, dipshit.
There you go, Arwen.
I'm saying light doesn't have mass. I'm saying that it's incredibly hard for you to measure mass. You have to assume mass. Okay, that's what I'm saying.
Light doesn't have mass. I'm not assuming that it has mass.
Well, photons assume that it has mass because photons allegedly have mass.
There's a mass energy equivalence.
Right there.
So yeah, if you want to talk about whether or not light is affected by gravity, then you can use the mass energy equivalence, and it is affected by gravity.
Right, you got your Schrodinger's cat dilemma here, but okay.
That's not Schrodinger's.
Not Schrodinger.
I'm saying it's a paradox in physics where you're saying it has an equivalent mass.
But it's not Schrodinger's. Did you just throw out another term because you wanted to sound fancy?
No, I'm just saying it is the same sort of paradox analogy where you have your cake, you eat it too, and it's in the septic tank, but it's also on your kitchen table. It's the multi-parallel universe
and
model.
Schrodinger's cat isn't a real experiment, so
it works. Phil, bro.
It's a thought experiment. It's just a thought experiment is what his thing was. It wasn't a real experiment.
So light has detectable momentum, but light does not have a rest mass.
Yeah.
If it does,
it can be assumed to have detectable momentum.
To get light to stop. So
you guys are claiming that light photons aren't affected by gravity?
No.
Photons are affected by gravity.
All right, so then they have mass.
They are affected by a force that is 10 to the 36th power weaker than the electromagnetic spectrum, and they're saying they can measure that.
Yep.
They're also not affected by magnetics.
They have measured it. They have.
They're saying they have, but that's insane.
Wow.
It's pretty cool. They have in fact measured it.
They're like, we can separate this 10 to the 36th power less forceful than the magnetic spectrum, in so much that everything we do on Earth, we just assume that it's done through the electric field, right? The field that we see magnetic interactions happening. But we've been able to theoretically on math say that we've found something that predicts that predicted it, therefore it has mass. You know, like we use this, we found something
with a magnet.
Yeah. Tim Davidson says this dude is extremely well versed in this topic. A real photosynthesis bro.
Oh, that's a nice little bit of wordplay, but okay.
So you can't deflect a laser with your magnet, right? So
yeah, that's the thing. It doesn't matter that whether or not it's significantly less in magnitude to electromagnetism, because photons are not affected by electromagnetism. They are affected by gravity. Really cool. Because photons are the messenger particle for electromagnetism.
It's weird. You should really look into quantum physics and how nothing is treated like really a particle in there. It's all field interactions.
Oh, thanks, bro.
Oh, field interactions are different than particle interactions. That's what the double slit experiment is all about. It's showing that, hey guys, this is really strange. Unless we use an apparatus which directly interferes with the electrical spectrum, we will never see any other result than a wave interference pattern. But when we have a measuring device which is directly altering the field, then we get particle effects. So it's like, come on, guys. Cake, eat it too.
Good job. You should publish this and get that expensive Swedish prize.
It's actually published. It's literally they confess these things. You can find tons of this.
They confess.
Like, Facebook doom scroller. You can watch reels where they'll be like, "Well, we technically don't treat stuff like particles, but we do." But
that's right. That's where you go. Facebook is the place for cutting edge science.
No, I'm just saying.
It's not
Facebook Reels even.
It's not that.
No, we're talking about science communicator.
Owner.
I just wonder if you can describe.
Owner.
Can you describe the
omnivore?
Yeah.
Owner probe.
It's not that the instruments are like affecting the wave. It's just that the instruments are only capable of measuring one part of the wave.
Okay.
I'm
just wondering if Lionel
can
explain what equipment he thinks is being used in these double split experiments he's talking about.
Emotional damage.
Sorry, I just had to play one.
Because I question whether or not he can do that.
No, I cannot tell you the exact apparatus being used. No.
So then how do you know that it's... So if you don't know the apparatus that's used, how do you know it's affecting the wave?
Because when you're not measuring it, you have to assume, quote unquote, if you're not directly viewing it, you have to assume that it's doing the other thing. It's only when you're measuring it. Yeah, it is.
So what you're measuring in the double slit experiment is the result of the photon or electron on a charged couple device, right? Some kind of plate on the other side that's recording the the photon.
It's a screen, just a screen. All you're doing is you're shooting a laser through a slit and seeing how it.
You're not shooting a laser.
It's a laser now.
Yes, you can use a laser, absolutely. You can do it with a laser, or you can do it with a photon gun, was what you would call it.
You can do it with an electron. You can do it with a photon, but generally you're firing just one. You're not firing a stream of them.
The initial one was doing a small number at a time so that you can isolate them. So that they you do one at a time, and it acts as one at a time. You see one interaction, and so it's acting like it's acting like a particle. But when you sum them up, the pattern that they make has a pattern like a wave. That's the duality,
right?
But they are still independent events. So here's a question from
I shoot a laser. When I shoot a laser for a short amount of time at a certain point, if I'm only looking at a very narrow window, it will not have time to spread out amongst the areas. You're saying one at a time, but what I'm seeing is this is the front point, okay, the dispersion happening at a single time. And all right, I'm misspeaking. I'll just retract and you guys can carry on.
All right. Well, Eric Burns, an astronomy teacher, is asking you, Lanolin, which form of EM spectrum has the highest energy?
That would be as you get closer into ultraviolet or into X-ray or into gamma ray. It's going to have the most energy because it's the most about a wavelength in the smallest amount of area.
There you go, Eric. You got your answer. Tim Davis says it's funny because he uses words wrong. Icy Spin says he's an investor in Witzett's Ranch Dressing Inc. copyright.
Oh boy, do we have
very
to
nice?
No,
you don't.
I mean, I'm a man just like the other men I would presume that are in here, and we make mistakes and we get tripped up in our words.
Can't touch this.
Thanks, Arwen.
And also, I don't want to, especially in fields where I have to rapidly calculate like what the intent is behind them. It takes a little bit, yeah. And so I'd rather just retract instead of try to, I'm not a know-it-all. I don't know everything.
So what? Maybe just to move the conversation along. What's the big disagreement with? I think there's a couple of disagreements. I've heard people say that upward refraction is actually downward refraction. And I don't know if that actually took place in this conversation. I was a little distracted.
I'm a stupid flat earther, right?
Maybe that's where it was headed. I'm not sure, but I know that there's a kind of a major disagreement somewhere in refraction. Would you agree, Lanolin?
Well, I think it was just a misunderstanding between me and it wasn't Toon. It was a different guy in here, where he was calling what is downward refraction. And he was mistaking the idea of downward refraction with upward refraction because he was talking about how the apparent position of the image, which you are seeing at distance, is lifted. And so he was saying it's being lifted, and he was conflating that with the idea of upward refraction. But if you're seeing a lifted image, then from its true position, that's really downward refraction because it's coming in from an angle which is higher than you, and it makes it look like that it's higher than you, as though, So yeah, I think that was the.
Maybe you could tell the other 98% of the flatties that that's the case, and also the celestial theodolite bros. You know them? They like to ignore refraction completely. Maybe send them a message too that you shouldn't ignore it.
I think QOP's working on a video against them. Am I wrong, QOP?
Oh, I know that's going to be good.
I'm trying to also show the globe side not to ignore refraction because they'll tell me that they use reciprocal theodolite angle measurements to measure, the surface, the geoid, right? And ignore the principal elements of refraction.
No, actually. We don't. No, we don't.
Yeah. Yes. Yeah.
So if you look at
historically,
if you look at the transcontinental triangulation and the American arc of the parallel, when they did their reciprocal zenith angles, they measured the temperature and pressure at the locations that they did it. And if you and so then all of that data that they published in 1900, a few volunteers typed it all in, manually typed it in to a spreadsheet on Google Sheets. You can look at it on my website, mctoon.net/SE. And you can have you just jump right to that, the whole spreadsheet right in there for you to peruse, and all the data's been entered. And then Walter Bislin took the temperature and pressure data along with the reciprocal zenith angles and applied refraction to that using the data that's there. And and of course, vertical angles like that are more susceptible to refraction, so it is something to be concerned about. So he did get concerned about it. He did the actual application of refraction and found that it matched the globe very well, and the amount of refraction that was being measured there is rather small. And to match flat Earth, it would require a massive amount of refraction with the other drag, the negative K value.
So what you were saying was very correct. In fact, I'm 100% with you in the term of they used the temperature and the barometric pressure. And in radiometeorology, we call this the dry term. Okay, but without the wet term, which is the measurement of the humidity and the surface temperature, you can't make your final calculation. So if you jump back in time, it's a little bit easier to understand where the field was because they weren't complicating it, so people couldn't get into it as easily. But if you jump back to like 1969 and Bean and Dutton, they actually had to suspend their calculations for their climatology maps until the United Nations supplied them with what they coined in their own papers, the fictitious value of the relative humidity, because you need that to be able to create a climatology map. You need to know if you're going to account for your density, where it's at in relation to the surface, you have to know your wet term, and that's only calculated by also knowing your relative humidity and your surface temperature. Now, in their models, what they did was they just used a fictitious value and assumed what's called supersaturation at the surface, which is where if you assume that at the surface, like let's just say 1 inch directly above the surface, that the relative humidity is at 100%, that will restrict the amount of off-gassing that the environment experiences from the surface, the amount of vapor being introduced at any given time. This creates an incredibly dry area above it. I mean, and not only that, it also means that basically you're just making the vapor pressure proportional to just the dry term, your standard air pressure, just temperature barometer. That's why if you look up the what's called a psychrometer, okay, psychrometer, that is what's called your wet bulb and your dry bulb that you're measuring. And that's because you have a wick on one of your thermometers, so that way you can get your relative humidity. And this was the traditional, experiment type measurement apparatus, because you have to have that. That's why there is a psychrometer in the history of radiometeorology. That's why they used it. You can't just use your temperature and your barometric pressure. And if you are, then what you're doing is you're creating an environment which is, for all intents and purposes, creating a uniform density gradient where it's always densest at the surface and less dense as you rise up. But they know you can't do that if you're actually going to really account for the environment. So I'd encourage you just look up a psychrometer. I mean, you wouldn't have that instrument to measure the environment if what I was saying was untrue. You need your wet term, you need your dry term. You can't just use your dry term.
Well, the nice thing is that Walter Bislin did all the work, number one. Number two, and you're going to like this, the line of sight is typically not skimming the surface, so that it reduces that particular issue by quite a bit, especially when they're in the Western United States. So give me a second here. What's that?
It's not about skimming the surface. The reason why I was saying they impose super is so you have an incredibly dry environment above it, so you can so basically you can invent on paper a density gradient, which is very close to the ground, that is densest really close to the ground, and then less dense as you rise up. What you were saying was Walter Bislin took temperature and pressure readings, but didn't take his wet term into account. Also, if you look at Walter Bislin's calculator, no matter how much you turn his refraction slider up, it never shows a concave Earth. His model will never show the horizon going.
All right, you're off talking about a different topic here. I'm not talking about that particular one. I'm talking about the reciprocal zenith angles that he measured. And I put the link in the that he applied the pressure and temperature values to specifically for the transcontinental triangulation of the American arc of the parallel. And the important thing that he did that you can look at here. Now we know the radius of the globe from other measurements and over, for centuries. And so what he did is, if you scroll down about halfway, it says observations from the transcontinental triangulation. And let's see, does he have I think he has dedicated page.
Thinking, so triangulation wouldn't really prove sphericity. You would still have the same thing where it works on a flat Earth with optics causing bottom-up obstruction. If you want to prove sphericity, you need something in the center of that triangle to prove that there's a higher point in between the three.
That's not what the triangulation is doing. That's not the geometry that it's doing. Actually, so the page, I'll put the page directly to it.
Can you explain? Because I'm pretty sure it's like a reciprocal zenith angle, but with three, right?
Nope, it's a different thing. We're not it's horizontal angles, not vertical angles. So, all right. I put the link to the specific one for the
reciprocal zenith. It's still theodolites pointing at each other, right?
It's not reciprocal zenith. They're horizontal, not vertical.
But they're three theodolites triangulating each other, right?
Horizontally, yeah. And refraction is different. Yeah, refraction is different. Yeah,
your zenith is up and down. And horizontally, again, if you're taking temperature and pressure into account, then on paper, what you're doing is you're saying there's downward refraction going on during this time from these 2 points, okay? Because it's always going to bend down if you're just doing temperature and pressure, always. I mean, it's always going to, unless there's a massive temperature inversion at the surface, and it only happened near the surface. So what I'm trying to say is when you're shooting these reciprocal theodolite measurements, that you're taking what is your dip angle, right? If you're going to be looking at, let's say, the horizon or the dip to the observer, right? And then those are going to be taken into as these are dips to the horizon with the idea that downward refraction is happening. So now you're taking what is the effect of upward refraction and applying it to a physical curve. Like you're saying that an upward refractive effect, which you're now interpreting as downward refraction, and this is how much the downward refraction is lifting the horizon, and you're saying, well, this is how much curve there is. And I'm trying to say, if upward refraction is happening, okay, when it's happening, and you're interpreting that as Earth curve, then there's your problem, because you're saying it's downward bending light when it's really upward bending light, and then it's going to make on your measurements appear as if your angles are diverging. Your zenith angles are diverging.
All right. Shh. That's enough. That's enough. That's enough.
All right.
All right. I gave the link. I'm ready to address it if you just let me talk instead of, another book that you read. So, item 17 on the link that I just posted there, Big Springs to Pike Peak, as an example. On the right side, he does the computation based on the temperature and pressure. Actually, the computation that he did here is the index of refraction that would be necessary to match the globe, which is 0.12. That's the column fourth from the right. It's called K of globe. There, calculate globe K, 0.12. And then the next one over to 2 columns, the index of, the coefficient of refraction necessary for flat Earth is negative 0.88. So a negative 0.88 coefficient of refraction is a not a reasonable value to be having over time, because as you talked about before, you're going to have air that has basically you have less dense air low to the ground and more dense air high to the ground is what's necessary to cause a negative index of refraction, or sorry, a negative coefficient of refraction like that. And to have a large negative coefficient of refraction is extremely rare and extremely unstable. So it shows that it's a reasonable amount for the globe, 0.12, and it's an unreasonable amount, basically impossible for flat Earth, negative 0.88. So to just say,
that's just your assumptions for a flat Earth being different than the globe.
We're just applying geometry, optics, and physics.
Well, the optics part you're butchering, because you're literally showing us a set of numbers, a table, which is completely ignoring one of the principal elements of calculating refractions. You're showing us the dry term, and the dry term is just a measurement of your temperature and your barometric pressure, and you're not showing us our wet term, which does do that. I mean, I don't know what to say. I mean,
so you think the wet term from Big Springs to Pikes Peak, which is a nowhere near the ground measurement, it's a significant change in elevation. Mm-hmm. You think that has a coefficient of refraction of negative 0.88? You honestly think that?
I can show you layers, right? I can show you a Fata Morgana, right, where there's independent layers above the surface, because light will bend towards the layer of relative proximity, the density relative proximity, meaning if there is a layer where water is changing states, meaning it's expanding, okay? It's expanding because as it comes out from underneath higher pressure, higher density areas, it will expand. And as it expands, you'll get inversions. That's why we can see Fata Morganas. Okay, it has everything to do with the humidity changing states. It has nothing to do with a extreme 15-degree change in temperature within a 10-feet area. It has to do with the change in the form of the humidic vapors. I mean,
I'm a stupid flat earther.
I'm just
right?
pointing
and
out that like this
loser.
has been recognized since on paper since 1836 that this is a massive problem for the globe. And they even detail like why they want to ignore it, why your tables are only showing our dry term.
I don't know why you completely ignored everything that I just said. I guess I know why.
I mean, if you're
it doesn't work for flat Earth.
Look, if you're on a mountaintop, right, you have to account for the fact that you get convection currents along the face of mountains. Okay, convection currents. That's where you
I'm a girl, and my dude's a wife, and we just somehow make babies or whatever.
You have forces that come up along the face of the mountain, and then sometimes on the other side they're falling down. And you do have to account for these things. Mountaintops are really hard because you have massive changes in the environment. Turbulence of the environment is a real thing. It's not to be ignored. And yeah, like I'm not exactly sure how you're using the flat Earth model and how you're applying it. Because you guys tend to strawman the flat Earth model, so it's hard to say that Bislin's being more honest here.
If only there was a consistent flat Earth model that we could look at, maybe written down in a book that we could look at. Oh, you know what? I have a stack of flat Earth books, and you know what? They all are consistently saying about the same thing about the flat Earth model, that it's flat, that it's a circle, that the North Pole's in the middle, and that there's 60 nautical miles per degree. That's about it. We don't get much more than that. And then when I say that, and I come on Discord, a bunch of people are like, that's not our model, you're strawmanning our model. Well, give me the model. If you're not going to give me the model, I can't be accused of strawmanning it if you don't have it.
It's very hard for us to make the model for the globe because you guys say we misunderstand it, because in the multi-parallel universe model, you guys just get to say
I'm a girl, and my dude's a wife, and we just somehow make babies or whatever.
Hey, Eden, can you stop playing that soundboard now? If that is you.
That was someone else, I think.
Probably Q-Op.
Yeah,
but
everyone,
what I'm saying is, in the multi-parallel
soundboard
universe model, it's basically we can have anything we want because it'll pop into existence when we need it. So it's
that's not it at all.
One particular,
that's not it at all.
It's the multi-parallel universe model. It is.
That's not what I'm talking about. That's not what I'm talking about when we're talking about identifying curve or curving surface. That's not what we're talking about.
That's what you say. I mean, you can say we're not talking about it.
It's not. It's not what anybody says.
You're not talking about it, and then
that's not what anybody says.
About it.
Not what anybody says.
It's absurd, man.
So anyway, if there's some different way to compute refraction for the flat Earth model, I'm certain that Walter Bislin would love to hear it and be educated. I would take that too on the physics, optics, and geometry involved. But so far, very few flat earthers even think that geometry is something that you use in science. Typically, they're like, "Oh, that's math. You can't use math."
About going from a curved surface of a globe to a flat map, and it turns out there always has to be distortions to do that. That's geometry, right?
Yeah, that is geometry.
Before you came in, we were hearing how you can go from a curved sky model to a flat model without distortions.
Oh.
No, we were talking about with an egg distortion applied to it, to where if you're headed towards the north, every degree that you go up, that you head towards the north, instead of for every 69 nautical miles, the Polaris will begin to slow in its climb towards your zenith. Whereas if you head to the south, the further away you get from it, it'll begin to fall more and more.
It will slow in its climb?
Yeah, so like it does. It's not.
Why would it do that
in the north as you head towards the south? It's not a perfect celestial sphere like it's presented to us.
What's not?
The star field, and I'm saying the star field wraps to the surface of an egg. Okay, and I'm not saying that this is inherently perfect, but I am saying that I've been told that counter rotations can't work on a flat surface.
That's right, they can't.
Well, no, if you have a celestial egg, which is coming through a toroidal lens, where the egg is suspended in the middle over the north, and it's
where's
rotating,
what toroidal lens?
It would be the lens above our heads, like Operation Fishbowl, when they're slamming bombs, which I'm sure they just had timers on instead of slamming it into the
you didn't. You should actually read about that. Some of those bombs, they went up higher, significantly higher, and they exploded on the way down, not on the way up.
I mean, you
should look into that
after you declassify something and just pretend.
Awesome. So you'll cherry pick. You just cherry pick whatever you want from that and ignore the rest of it. Only take what matches your pre-assumed conclusion.
Because the government released
everything that doesn't match your pre-selected conclusion, you'll ignore.
Are really true. I'm saying the government says that they're doing dark secret things, and if your source is solely authoritative from the government, then you got a problem, because you got a trust in government problem, where you're saying
you're the one trusting in the government. You're the one trusting in it, not me. I didn't bring up this thing. You did. You're the one trusting in the government, not me.
No, I'm saying look at their stuff. They're exploding bombs. They're crashing bombs into things, or I would assume they are.
So I mean, I can't. I don't know. How do you know that? You're trusting the government to say that they did that.
In a lab, can we get a bucket
I'm
of
saying
LeBron?
that if those images are real, which I can't verify that they are, but they're testified to be real.
One trick is to tell them stories that don't go anywhere.
So, right. So you're saying, well, I believe that this Operation Fishbowl thing, you should look at it, but then when somebody points out that it disproves your model, you're like, oh well, except for that.
Never mind that part. That doesn't work.
Because Omni said it.
No, what I'm saying is, if the images are real, if you watch the images, all the sound is redacted. I'm not sure if you guys know this, but they had optical recordings on
I'm a
film
stupid
at that
flat
time.
earther, right?
So
and I'm just a loser.
If they can record audio optically, why is it all redacted from the imagery? Okay, that's a problem.
How did you measure how high they exploded them?
A little bored though.
No, that's what I'm saying is you can't verify how high they exploded without reading.
Oh, so you don't know. So all this is nothing, and then a bunch of nothing, and then on top of that some more nothing. So
that's what I'm saying.
you want to ignore everything from Operation Fishbowl.
You said what surface is above us, and I said, well, just like kind of.
And then you appealed to the government. Then you said trust the government, bro.
In some instances, I go to the government, like I go to
when it matches your pre-selected conclusion. I got it. It's part of the anti-scientific method I just posted again.
No, not when it matches my ideas.
Exactly. Not when it matches your ideas. When it matches your ideas, then you accept it, and when it doesn't match your ideas, you'll just hand wave reject it. Got it.
I am saying that there are specific instances which seem incredibly distant from any sort of like globe manipulation or whatever, where it seems like, if they were going to be lying right now, that seems a little bit weird. Like if they're going to have bombs exploding in the sky and say that they did that, it might be genuine. I'm not saying it is, but it might be. And I just wanted to bring it up as an example that when you look at the images, it doesn't really look like a ball exploding. It looks like it's slamming into something. I'm not saying that this proves anything. I'm not saying that I even believe the imagery. I'm just saying based on the imagery they provided,
but you did.
It really does look like things are slamming.
But
no,
you 100% did.
I believe 100% believe that it
because
happened.
when I asked for evidence, that's what you gave.
Pause. We're going in circles. Can we go back to the optical, like toroidal nature of how the South might work?
Yeah, how does that work? Give us the physics, optics, and geometry for that.
Sure. Let me just post a picture. I've already posted it once, but I'll do it again. One second. Here we go. I'm putting it in the. I think I'm in. Yep, I'm in the main text chat right now. And it's uploading, and there it is. So you have a celestial egg in the center.
I heard someone is going to lie about the South. Let's go.
Yep, that's funny. I mean, talk about poisoning the well. All right, so there's the celestial egg right in the center. That's where the depth would be of the star field, and you have the fatter bottom. So the angular rotation of the egg is the same. Where you have the fatter bottom, when you look towards the north, that's going to cause a slower rotation when you're looking towards the north. Whereas, I'm sorry, it's going to cause a faster angular speed rotation because it's a fatter bottom rotating at a same angular speed as the top, but it's stretched across a bigger distance. So you're going to have an increased speed of rotation in the north, but it's being projected over a smaller area. Okay. So it's going to slow it down. Whereas when you have the top of your egg, right, it's angular spinning the same as the bottom, but it's a smaller area being projected over a larger area, which is going to slow it down. Okay, so you have geometrically, you have the mechanisms required for the star fields to be rotating at the same speeds in the south and in the north. You also have the mechanism for the counter rotation, because it's being projected from the top to the observer looking towards the south. This is like a ceiling fan. When you look up at a ceiling fan, if you're looking up at it, it's going to rotate one way, and then if you can position yourself above it, it's going to look like it's rotating the other way. All right.
Oh, like
how did we get above the ceiling fan?
I'm a stupid flat earther, right? And I'm just
you got above it because the light is being refracted from the egg.
I'm a stupid flat earther.
It's being refracted from the egg? How's it being refracted?
It's being lensed. Well, it's the same thing when you go through a camera lens. Like, how does the camera lens take light and project it onto a sensor? I mean, it's the same idea.
Okay.
It's being refracted through a medium that God created, and I am appealing to God when I say He created.
Okay, it's just magic. All right, God, it's all lens. It's all magic.
I have a question. I have a question. I have a question. So the
I'm a stupid flat earther, right? And I'm just a loser.
All right, thanks, Woodsit. So would the southern stars rotation be created by the extremity of this like oval shape, like in the south or something?
No, it's what's creating the star rotation is the fact that you're taking from the top of the egg an image from the top of the egg and then bringing it as though you're standing above it looking down. Okay, which is the same effect as if you're looking up at a ceiling fan, right? It looks one way. Okay, and then if you cut out the ceiling and you just have the fan spinning from the other side, it'll look like it's spinning the other direction. Well, you're seeing it as though you're looking down at the egg, whereas when you're on the north side, it's as though you're looking up to the egg. So you're getting a counter rotation effect because it's being projected to your eyes as though you were standing.
You don't have a model.
Objection.
Wow.
That would mean
this is insane.
I'm a stupid flat earther, right? And I'm just a loser.
We would see the North Stars inverted for the South, and the problem is that it's totally different stars.
Inverted? What do you mean inverted?
Yeah, if it's a reflection, if it's like
projection,
beaming down or whatever.
Projection.
I think he says that there's different southern stars that we magically see coming from somewhere else because of magic.
You're seeing the southern stars from the north of the egg. Okay, you're seeing because you can't be in the north and the south.
What do you mean
at the same time?
The southern stars are north of the egg?
No, they're on the top of the egg.
The top of the egg. Right. Okay, so they're on the top.
Which came first, the earth or the egg?
And so when we look up, when we look up, we only see the stars that are on the bottom part of the egg, and the stars that are on the top part of the egg we don't see because they're too busy being magically refracted to only be visible to people in the south.
They're being projected to different parts of the earth. Yeah, you're saying magically, but again,
it is magic. Pure magic is what's causing it to happen.
There's
no geometry, optics, or physics that would cause this to happen.
No, that is a geometrically, optically correct model.
No. This would not cause that to happen. All you have is a drawing there. You didn't describe the refractive conditions necessary. You didn't explain how where, plot out on this surface here that you say where each of the stars are, because the stars have a location, right? So where are the 4 stars of Crux on this? Where are they?
Be near the top of the egg. Yeah, near the top of the egg. I want to say something. Hey, hold on. Let me get this out. All I'm showing in that model is the process of unwrapping. So you guys use this all the time to unwrap a sphere, the globe, onto a azimuthal projection map. That's what this process is. This is the very same mechanism, except I'm saying instead of using a celestial sphere, let's use a celestial egg. So you're saying the optics don't work, whatever, but it is fundamentally the optical process to unwrap the egg onto a flat
It's not even an egg.
It is an egg. I'm showing it in a 2D representation, but I'm showing it as this is just 2D.
Is the egg the dark turd in the middle, or is the egg the 2 circles around it on either side?
Right. So there's those circles, those little blue hue circles. Those are just representations of a three-dimensional lens.
Okay. What are the dashed lines?
That represents the light path, but truly, if you look at those dashed lines, that is the true shape of the lens. But the end of the lens would actually touch down at the perimeter. I just drew this. So it's again if they're going to soundboard me, that's just a way to try to present to your audience disruptions, and it's honestly incredibly dishonest.
I don't know. There's flat earthers in here doing this on boards too. I don't know who's doing it.
Yeah, but it's
you know
what's
dishonest? What's dishonest is lying about the South.
Yeah. That's what you're saying.
I live here,
and I'm accounting for Southern Star rotations. That's what I'm saying. Is I'm geometrically optically.
So here's. All right, back to the question here.
The whole world because you're the omniscient one. Okay, we know that.
He is.
I'm saying you guys presented this idea that can't happen on a flat Earth plane, and I'm just saying, hey guys, your azimuthal projection map is literally the same process, and because we're looking at a star field and not geometry like globe positions, it's all you're seeing is points of light. So
Dunning-Kruger knows more than everyone in the world.
Yeah, what I'm saying is you guys are saying there'd be heavy distortions in the star field. It's no, because optically this is going to make, if you're at the equator, things appear to go straight across your frame of reference. Because you're looking at it also lets the sun disappear. So if you're talking about how you're about to do this measurement right in Pensacola, right, and you're going to see the sun and see if it changes angularly. Well, the sun in this model is actually traversing across the surface of the egg, and it's actually kind of in a sense orbiting around this egg. And as it goes around the egg, the density of the egg increases and is going to cause a cutting off effect of the sun as well. So you not only have the optical horizon cutting it, but you also have the geometry of the egg cutting it. So, this explains a lot of things. It also, if you look at my model, explains the polar vortex that we see.
It doesn't explain anything. It explains nothing. It's just wishes and prayers is all it is. Because you didn't do any geometry, optics, or physics. You drew a picture and then you just said, oh well, the light has to take this path. No idea why it would take that path. No idea what would cause that to happen. I'm just going to say refraction. I'm just going to say refraction causes it to happen, but I don't know of any material there. I just hope that there's material there.
I believe it's a crystalline, malleable, sort of maybe super.
I don't care about your religious faith about that up there.
Hey, but MCToon, you guys say,
right?
Well,
and I'm just a loser
out there, and we invented that 40 years before we're even claiming, maybe 60, 70 years before we ever even claimed that we have any evidence of it. Now that images can be faked and data is so fake.
I don't know. What are you talking about?
Dark matter. Well, I'm saying you're saying you're just inventing something.
Words
and
are hard.
Invented dark matter.
Dark matter is a hypothesis. Hold on, dark matter is a hypothesis.
This is the hypothesis too.
That's what. Yeah. The difference is that your hypothesis directly contradicts known optics, physics, and geometry.
No, it doesn't.
Yeah, it does. There's no you didn't produce any of these things. You didn't produce the actual geometry necessary for it. You have a drawing. That's it.
I have a drawing which
Okay,
is.
you're just repeating yourself. Max, did you have a question?
Yes. What shape of
What is the
lens
nuh-uh
would
back and
get
forth?
you an im? What shape of lens would get you an image inversion?
An image inversion?
Mm-hmm.
I need to be okay. I want you to be a little bit more specific, because if you're just asking for an image inversion, it would be one where if you're looking in it from the bottom where the density is lower of the lens.
Yeah. What shape is the lens?
Gosh, dude, you can have image inversions with all kinds of shapes of lenses.
Okay, start.
I mean, one can be a triangular prism, for example. You can get an image inversion with a prism, with a triangular prism.
Do you have any way to demonstrate that? Because as far
look
as
at
I know,
look at the Pink Floyd the Pink Floyd thing. Just turn the prism upside down and then view it from the side. There you go. You have an image inversion. Like, what the heck are you talking about, man? There's all kinds of image inversion shape lenses. It depends on where the density is within the lens or which angle you're viewing it from.
Yeah, the correct answer is a double convex lens. Sorry, thanks for playing.
No, I'm just saying, like, if you're fishing for a certain answer, you're not getting it, because I just explained several different versions of where you can get an image inversion. That's why I said it's like.
And you demonstrated 0 of them, so I'll take the win. Thank you.
Yeah, you say it's a win, but that don't make it one, man. We're just gonna go back and forth. That's what it's come to.
Thank you, MCToon. Thank you, Max. Out of the gaps explains everything.
So here's a question. What causes boats to disappear over the horizon and they can't be brought back?
Right. I just showed an observation earlier where instead of me going over the horizon, disappearing bottom up, I literally just vanished all at once. But again, boats disappearing over the horizon could be a multiple of things. One, it can be just upward refraction. Okay. It can also be a combination of upward refraction combined with less upward refraction in the near field. Yeah.
Or the magical sky lens that does it too. Whenever you get in trouble, paint it in a quarter. The magical sky lens does it. Solves all problems.
But you guys are saying that you guys have all kinds of magical stuff happening in the sky, like dark matter. I mean,
completely different topic.
No, it's still optics. You guys are saying optically we're looking out into something and it's doing something optically different, because that's how you're measuring it, is with optics. So you're trying to make the optics make sense, and to make the optics make sense, you're imposing dark matter into the field.
Yeah, you guys are claiming like supermassive objects in the sky refracting, starlight around galaxies and crazy shit.
I mean, you're making huge claims about
things that have been empirically confirmed. All things that have been empirically confirmed. That's what's awesome about it, is that we don't need to go and invent magical sky lenses to solve problems.
I empirically measured the density gradient on Lake Testamina as I shot a laser from I took a camera with a Laowa 0D 12mm lens where they show their lab measurements of how little distortion this lens has. It's less than 0.5% across the entire frame of the lens. Okay, it's got a 122 degree field of view. We took density measurements at Station A and Station C, so 12 miles down the lake, and at the original station where the laser is being shot from. We set the camera up, okay, perpendicular to the laser. It was 3.5 miles away at the center point, and 6 miles.
I'm a
at
stupid
the
flat
furthest frame,
earther, right?
And
I'm just a loser.
To the far right side of the frame. Okay, we took our picture, and then we did all the calculations we needed. All the calculations of the environment. When I say we needed, we just did standard radiometeorology calculations of what we measured. Okay, we got our temperature lapse rate, which we actually have 2 temperature lapse rates, because you have to have the temperature lapse rate of humidity and the air, so your dry term and wet term. And we took those and we plotted them, and it's so weird that our plot matches our picture, where we have an upward bending beam, okay, with a downward bending ground. We can see the source of the laser, the divergence coming from the source of the laser 6 miles away, which is only 3 feet above the surface. My camera's only 3.5 feet above the surface. And we have the locality measured where light is bending up across the entire locality. And so we know that light has no mechanism to bend down and around the surface of a globe, and because of that, it's like, hey, man,
why would wait?
No
we don't know. What do you mean we don't? We don't know that? What are you talking about?
I know it. I know that there is no mechanism for light to bend down when the environment is causing upward refraction, not just optically where you can see it, the hallmarks of it, whereas you can see from a position too close to the ground that the world appears curved, where you wouldn't be able to see it no matter how wide your lens is. Okay, we can see this downward bending ground with an upward bending beam. We can see all the way to the source of the beam, and it's 6 miles away, too low to the ground to be seen, without without a downward bending mechanism, which there is none, and we are witnessing in frame that there is upward bending light, not just by the horizon, but also the beam itself. And the mathematics also show that this is exactly what we would predict. I mean, exactly what should be. I mean, it's exactly the measurements. I mean, if you just apply standard radiometeorology without any impositions like supersaturation at the surface, you're just using local measurements. That's what we got. That's what our picture showed. Earth's flat.
So you're one highly chaotic refractive conditions. Therefore, all other refractive conditions are unknown other than this, and everything else can be ignored. Got it.
Actually, it's incredibly stable.
Dunning-Kruger, aggressive Dunning-Kruger.
No,
and you think you're going to have the most comprehensive publication on refraction ever published, yet you haven't actually done a survey of the annals of science to find out that there's significantly more detailed refractive publications already in existence.
No, I'm saying
you just didn't even look for them. You didn't even look.
No, I actually have hunted through so many and found so very little. Like the Rainier Lake experiment, it's nothing compared to mine. Okay, I'm talking about publicly, freely accessible.
Yes, you're the one that knows more than everyone in the world.
You don't have to pay for it. It's all presented, and people can look at it for themselves.
Where can we find it?
It doesn't exist yet.
Well, not yet, but it will be.
On the other hand, I just put a link in the chat there to a list of more than a dozen.
Why are you rolling him? Let me
hold on, Baboon.
Right, so there is radio sonde graphs here. I'll post my links. I'll post my links for my YouTube channel and for my Rumble movie, which I made about our observations out on Testamina. It also covers the history of the motion picture industry and some other things. But
may I make a comment? May I ask a question? In your laser experiment, did you consider dispersion of the laser beam?
Now he's in trouble.
Okay, so our half angle, so the divergence on our laser beam is, I think, 0.121, I believe. It might be a little less than that. I would have to go back and recalculate what it was. I know that at a quarter mile, so if somebody wants to go do this, this is how we did it. At a quarter mile, with an initial beam diameter of 1 inch, at a quarter mile, it was 3 inches. There you go. So if you want to go calculate our half
angle. How did you measure that?
How did I measure that? I shot a known quarter mile, and we measured our half angle.
You measured the half. You measured the half angle subtended by the laser.
Yeah, we literally took a tape, shot it at a target a quarter mile away, and said, "Hey, look, it's 3 inches." And then we took our initial beam diameter.
Hang on, but you were saying that you were saying that you'd done it over extreme distances where refraction could not explain the laser hitting the mirror, right?
Whoa! What are you? What?
So the whole point of this experiment is that refraction effects can't explain why the laser hit the target, right?
And
now you're talking about quarter of a mile, 400 meters.
I mean, when you say it like a target, you're making it sound out to me like you're saying I'm aiming it towards me, but that's not what I'm talking about. Like, yeah, in a way you could say it hit the target, but it's really like the transmitter to receiver. I understand that could be interpreted as target, but we were shooting it perpendicular to the receiver. Okay, so we had 12 miles of beam in frame at one time. 12 miles. Okay.
But did you measure the dispersion when you did it at 12 miles?
It was the same because we had it taped off. We
How
had
do you know?
Because we taped off our laser. We checked this. We calibrated our laser ahead of time. That's what we did.
No, that what you obviously think that your response makes sense. Did you measure from the top of the laser signal to the bottom of the laser signal?
Not at the time of shooting, no, but I also have
another... No, then your experiment is worthless, right?
No, you're saying it is, but I'm saying it's not. I'm saying that we know this.
Well, that's just an assertion on your part.
No, because I have other observations.
I'm a stupid flat earther,
look,
right?
I've got
and I'm just a loser.
Where we shot the laser across the surface and we can see it touching the tops of the ice chunks that stick up. These are 1 to 2 feet tall. We can see it touching the tops, okay, of it. And then I can see, oh my gosh, these people on their soundboard, they hate when I talk. I mean, that is your audience being so disingenuous.
Well, to be brutally honest, mate, you talk a fucking lot and you never shut up.
The people do.
So maybe if you talk less...
Hey, bro, mute this guy.
Tony, you're inventing a problem that doesn't exist.
No, I'm not inventing a problem, sir. You're ignoring a problem that exists.
Trolling fucking Lanolin. Let Lanolin finish.
No, so I have an observation where we shot the laser horizontal to where it was so perfectly horizontal above the lake, it was just skimming the ice chunks on the bottom. Okay, and we can see it.
I'm a stupid flat earther, right? And I'm just a loser.
We can see it hit 10 miles, but below the tree line, and yes, we can see the top outside of the half angle in the trees, and we can see where the half angle isn't spreading out the way that the full angle is. That's why we took our half angle measurement, is because at an extreme distance, we're talking about, like, at 6 miles, my laser beam is only like, I think it's like 4 feet tall, 6, something like that, you know, and that's my half angle. That's what my camera actually captures, is the half angle, because everything else is too dim. So, like, in my laser, all I'm seeing is the half angle that can actually be picked up by my camera.
I'm a stupid flat earther, right? And I'm just a loser.
Shoreline, because it hits the trees and we can see them actually illuminating the trees, we can see what the full angle was. And so I know for a fact that, yes, my half angle is an adequate measurement of what the beam is doing, because I can see what the full angle looks like when I'm hitting the shoreline, as opposed to what the beam looks like when it's traveling across the surface.
So like that, can we get a
you're saying, oh, I didn't measure it. It's like, dude, we pre-calibrated our laser on purpose. We knew what we were doing. We knew what we were going out to prove.
I'm a stupid flat earther, right? And I'm just a loser.
All right, stop the soundboard, people.
Yeah, it's disingenuous.
I've got a question for you, Lanolin. I'm presenting an image right now. Can you see my screen?
Let me go to it.
It'll start over in a second.
It's wearing me out. I'm getting tired.
Yeah, I got you.
Let me zoom in. Let me see if I can.
Yeah, let it reset. It's almost at the end.
Can you like control, like scroll wheel up
it.
and maybe like, because I might zoom it in or something, make it bigger, like control and then scroll wheel. Yeah.
Is that better? Shoot.
Go back one. Yeah, go back one. Right there. There we go. Oh, yeah.
That other one was a little more interesting. I don't know what you're talking about.
Yeah, I'm not sure what's going on. Okay, get out of here, Pony.
Yo, I don't know who muted PhD. I'm talking. I don't know who muted PhD Tony, but you got me blocked, PhD Tony, so I can't unmute you. So you're kind of fucked.
Okay, so I'm watching it.
All right, yeah. So this is a cruise liner, and I think it's Space Christian is what he goes by on Instagram. He's got a lot of pretty good videos, but this one in particular struck me because as the cruise liner, it's a big boat, right? Like cruises are awesome, but regardless, there's thousands of people on this thing. So it's easy to see when it sort of disappears from the bottom up, a lot easier than, say, a speedboat from Thunder.
Right, you see that inferior mirage right there, though? That's happening. That's what I'm like.
Well, yeah.
Yeah, and so that would be indicative. Like when you see an inferior mirage, people tend to think that's only happening like a few millimeters above the surface, or maybe an inch or two, or maybe a foot. But realistically, when you're seeing an inferior mirage, when you're accounting for the environment, it's actually.
Well, what about here?
Yeah, right there. There's.
What about here when it's?
Right there. You can see it. Look very closely at it, and you'll see there's a slight inferior mirage occurring still.
But where's the rest of the boat, though?
Well, it's being blocked by the optical horizon. I mean, that's what I'm saying. Is there's an event horizon. I call it an event horizon. I'm not sure if anyone else has dared.
Nobody calls it the event horizon. It's not the event horizon.
Into the water.
Yeah. Why is it causing the top of the boat to move down? That's weird.
Stretch down, upward refraction. Because I mean, guys, that's what happens. Things appear to sink if they're entering areas of more and more upward
magical
refraction.
sky lenses.
It has nothing to do with the magical sky lenses.
No, everything is magic. You just everything is magic.
No,
it has to be upward refraction because you pre-selected flat Earth.
You can see it. No, you can see the upward refraction in that shot. And also, I'll make this just based on what I know. If you're experiencing upward refraction near the surface, and it's not experiencing supersaturation right at the surface, your vapors can be lifted incredibly high. Like it can be lifted up 200, 300, 400, 500 feet. And the reason why is because the clouds had to form somehow, guys. You have to get vapor up there somehow. So to get up that high, it had to climb that high. And the globe model literally imposes an environment where clouds cannot exist when calculating their refractions. They call it the dry term. And that is when you just use your temperature and your barometric pressure to calculate your refractions. That's why the Walter Bislin calculator, when you move the refraction slider all the way to the right, it will never cause a concave Earth to appear, even though with theodolites we can show very clearly that a concave, now I'm not saying the Earth is concave, but it causes a negative equivalent radius. That is a fancy way of saying a concave Earth on the globe model. And the major limitation of using the temperature and the barometric pressure for your model is that it restricts it to just changing the radius into a bigger sphere or a smaller sphere, which is exactly why Walter Bislin's calculator, no matter how much you turn up the K, which is the refraction coefficient, it will never cause your model to cause a concave appearance, even though we can show that happens out in the world. Okay. That's what I'm trying to present. I'm just showing, like, whenever you guys say you're accounting for refraction, you guys are really ignoring one of the principal elements every single time.
Yeah, and you just make up wishes and dreams about how you want refraction to go.
No, I can show you paper.
to help your magical sky lens and your magical upward refraction. Magical upward refraction whenever you need it to happen to make the Earth flat.
Newton himself ignored humidity in his refraction tables in the 1700s with like optics principia and all of that. His tables completely only show the temperature and the barometric pressure.
Yeah,
Jean-Baptiste Pilot.
Yeah, therefore there's always the exact refraction you need to make Earth flat because you pre-selected Earth flat.
It has nothing to do with exact.
That's what I got it. It's okay. That's what you're doing. I see it.
There are days when the upward refraction would match the globe model very well in terms of if you're just looking at it optically. So if you're just looking at the optics and you're not thinking about refraction and you assume light travels in straight lines, there are days when optically it will look like the globe model is occurring. For example, I have a day when optically, if you're looking out, I appear to disappear behind a very hard, crisp horizon. But it's because there are objects that are above the surface 1 to 2 feet, which begin obstructing me because the refraction in the near field is very light, whereas the refraction in the far field is extremely aggressive. And because it's super aggressive, it sank down more, and these objects are taller. Usually this happens with water too, because there's usually wake, okay, water waves, okay, and it can cause a crisp horizon. But even in my own observation, where it looks like I'm going over quote unquote curvature when light was measurably bending up that day, even on that day, I'm 6 miles away from the camera and I should already be obstructed by Earth curvature. Okay, but I'm getting a inferior mirage, which can be seen in my documentation. So that's what I'm saying. If you guys disagree with me, that's fine. I'm just saying radiometeorology always has to account for the wet term and the dry term. But in present day radiometeorology, they're imposing supersaturation at the surface. So that way the vapor pressure is proportional to the air density.
Yeah, and you know better than they do, right? You know better than any of them do, right?
Admitted in the papers. I mean, Andrew Young admits he's using hydrostatic equilibrium in his paper.
Yeah, and you know better than Andrew Young, right? You're more expert than he is.
In this instance, he definitely is claiming it because he needs to use it for his calculus models. I'm not saying I know better than him. I'm simply saying he's full.
I hear you. I hear you loud and clear that you know better than all of the experts in the world on this topic.
That's not what he's
I'm not saying
saying.
that. Those are your
No, I hear it.
words,
I'm getting
I'll
it.
gladly take your accreditation if you're giving me that, but I'm not saying that. If that's the conclusion you came to, because I'm not actually saying those words, then I gladly accept that praise, even though I'm just going to give it back to Jesus because he's the one who's given me all this.
He gave you all these lies? Oh, gross.
No, he's not the father of lies.
Yeah, but you're lying about this. You're lying about the shape of the Earth.
If
You're lying about the magical sky lens.
8,000 years talks to you and told you these things, you are more than schizophrenic.
Here, I'm just going to screen share, and I'm just going to go to a few documents, and if people want to follow
All right, you know what?
along,
I'd like to
just for a
hear
moment.
PhD Tony pick up where he left off because he kind of got cut off in the middle there.
Say, right here, it says, on this basis, it was decided to use the long-term means given in the United Nations monthly publication Climactic Data for the World. This publication is particularly advantageous for our present study since it reports the fictitious value of the relative humidity needed to obtain the actual vapor pressure from the standard vapor pressure of the reported mean temperature. What's he talking about? This average N differs from the true average since the intercorrelation of pressure, temperature, and humidity is neglected. They're using a fictitious value. It's admitted in the papers. This is Bean and Dutton 1969 to come up with their models. By it, you know, he talks about how they're going to say, like, if we go here, this is from 1836.
Yeah. Therefore, all of the refraction necessary for flat Earth is true. Right?
Well, what I went to is
that's what you're saying.
The Bean and Dutton one. I'm saying the Bean and Dutton one was Ruhif. He used to share these radio sonde graphs, which he called measurements of the refractive index. And so what I did was I went to the source papers for those radio sonde graphs, those interpretations of the data, and I went and looked at them, and it's like, oh, look at what they're doing to the environment. They're actually forging the environment, and then they're graphing it. And then he said these were perfectly accurate. And then they're saying these are terribly inaccurate in the papers because there's an error because of the instrument lag, which is going to cause this density smoothing in the sense of it's going to be super dense at the ground, but it's going to look less dense as we go. And they admit it in their papers. He's saying these were extremely accurate, and they're saying these are terrible. So yeah, like
you should go teach all the.
That sounds quite honestly like a deliberate misinterpretation of the literature. If the literature says something like we can significantly improve on the accuracy, that's not necessarily saying that the previous results are terrible. And again, this comes down to the point that MCToon was making, which is you are assuming that you are better qualified to correctly interpret the literature that you are reading than experts in the discipline. Whose ability to correctly interpret this data has been assessed and has been found to be more than adequate. So you're just asserting
according
that
to
this
you.
Is no, they have been assessed and they have been found. This is what the accreditation process is about. You have no qualifications that have been awarded to you by experts in the field. You have no real world expertise by which we should I do
have real world expertise. I went out
hang on, look. So you got to talk. You've been able to talk for fucking hours, and as soon as I start talking for 2 minutes, everybody's over talking. I'm not ad homing. I am explaining.
Let Tony finish what he said.
How accreditation works. There are multiple ways for adjudicating whether or not somebody is an expert in a field. One is, do they have real world accomplishments in the discipline that they are commenting on? What are your real world accomplishments in this field?
I just presented several observations and measurements we recorded. I just went over them.
Those aren't
these are real world accomplishments. Yes, these are real world accomplishments. They are extremely
So you asserting?
Okay, you're saying they're not.
You asserting that? So the other, all of these rely on external assessment by subject matter experts. Peer review, it's not an ad-hom, it's a statement of fact that without assessment by peer reviews, by subject matter experts, any idiot can assert that they are, and any idiot is asserting in this particular instance that their interpretation is worthy of respect. We have subject matter experts. Your expertise is not accredited by them.
This is just something you've repeated to other people, I've noticed, Tony. Why don't we just focus on, why don't you critique what he's presented, please?
Yeah, exactly. He's attacked his character for fucking 3 minutes.
Yeah, so this was just a big nuh-uh. Like, you're just not accredited, so nuh-uh. I'm gonna simply go over Jean-Baptiste Bayet. This guy is accredited. He's considered one of the founders of refractions, right up there with Newton. Okay, if you didn't know, Newton was most people don't know that Newton was one of the first refraction modelers for terrestrial refractions. But again, let's just carry on. I wanna read this to you. So right here, we're talking about, I believe this is Cramp that he's talking about in his paper. He says, however, he still lacked the true values of the physical constants, and the uniformity of temperature he adopted is not...
You're welcome. I'll pause him for a second to read a few things. Hakraman says, Oakley going up the screen looks like a big dildo. Yeah, it kind of did. Guy Carlos for $2 says he exponentially assumed. Yeah, this guy, like, he's working hard to sound fancy, right? He's looked at these things, most flat earthers don't, but you got the witsits that do, right? This guy's just a witsit wannabe, it sounds like. So he's like, oh, all this stuff is this refractive model isn't exactly this, and that, right? Yeah, there's no absolute perfect measurements here, and there's no absolute perfect understandings of everything. But therefore, all of the refractive conditions necessary for flat Earth, which are significantly more difficult to have and unstable, those are definitely the ones that are definitely happening because magic does it. That's what's ridiculous, right? Yes, our margins of error can be improved. Our understandings of the exact conditions can be improved. But that doesn't mean that the incredible, ridiculous amount of refraction upward that's necessary for flat Earth is there. It's just not there. The thing is, as he showed, when you get high refractive conditions, you get a lot of optical effects. If you remember at the beginning, and I asked him, there is the horizon, the crisp line between the white snow and the mountain, right? It wasn't crisp. It was all over the place, up and down and jaggedy and everything like that. That's not because it was waves. That's because refraction was doing incredibly chaotic things. The worst possible conditions to be doing anything. When you see those kinds of effects happening over water, for example, don't trust it. But when you see consistent conditions, that's a little more trustworthy. If you can do it on the morning of an overcast day, for example, that's even better. But flat earthers, they don't want to do that. They always wanted to go to the absolute most chaotic conditions. That's what they like. They have to, in order to cast doubt and uncertainty into people's minds about whether or not the actual real measurements taken when these things weren't happening, to cast doubt on them. Tim Davidson says, what do you mean in the field of study that deals with things smaller than particles, things aren't measured by particles? Yeah, he denies all science, basically, right? And it's, Christians don't like that when he talks like a Christian, like when he invokes Christianity as the source behind all these lies. Not cool. Tim Davidson says Hubble saw line of stars they thought was a galaxy edge on. But James Webb provided evidence it's in a rogue black hole producing stars out of its contrail. Oh, that's cool. I didn't know about that. That's neat. Earthly Skeptic says, ask him why Polaris is not seen in the southern hemisphere. hemi-refraction, because of the magical sky lens. That's it. It's the magical sky lens. How does it work? Well, you can just draw lines on a screen. That's how it works. That's it. That's it. It's so desperate. So much desperation. Think about it, right? Here's the egg, right? North Pole is underneath it here. Right? North Pole is here. And then up here is crux, right? And then there's people over here on the surface of flat Earth that see crux because the light goes like this. Simultaneously, there's people over here on the surface of flat Earth that see the light because the light does this. It comes around onto this side, right? It comes from this side, loops magically around, and then comes down to be seen to the observer in the southern hemisphere over here on the opposite side. There is no optics, geometry, or physics that can explain how that would happen. It is asinine to suggest something like that. Dishonest, just don't care about truth at all is what you have to do. Nice and 6241 says, why do flirts always argue about quantum/theoretical physics when they don't even understand middle school physics? A good point. This guy seems to have a little better grip. He might have actually passed algebra, unlike Witsit. I don't know. He's like, I'm going to show you all the calculus, and then he put the stuff on the screen, right? He's trying to talk big. None of those formulas that he had on there were calculus. It was basic algebra, like algebra 1, 9th grade algebra. That's what it was. Icy Spin says, Z's in the chat if you've never been this bored. Yeah, that guy loves to talk. Oh my gosh. He can't talk enough. Like he could be in a Discord server all by himself for 7 hours. Kango44 says, if any flurf can show bottom-up obstruction that matches what we see in reality on any other shape than a sphere, I'll eat my own knob. I guess if you're... I mean, Nathan's been working on that flexibility. Kango44 says, and not in a good way. Oh my gosh. Call Badger Dude says, this has to be why QOP is the new Flurf Golden Boy. He says things in such scientific sounding manner, but it's all utter nonsense. That was lanolin, not QOP. QOP, QOP is goof. Icy Spin says, well played, lanolin. Bore the Globers, Flat Earth wins. Yup. Well, Kevin Bacon is getting some time here. Says, God knows that you paid for it. Enjoy your ball, boys. Good job, Kevin Bacon. You're a horrible person. Keiko44 says, most importantly, I have onion on my belt. Hold on.
I don't really know what I'm doing.
Oh, Arwen, what do you think is the problem with lanolin?
You're infected with Bob Tardation.
Oh, that's a bit mean. Arwen, that's a bit mean. Kind of back off a little bit on that. Tim Davis says, hey, DMOC, the radius of the Earth plus distance to the clouds. No, shut up. Yeah, DMOC, he just doesn't. DMOC and lanolin. Oh, my gosh. Kango44 says, fatter bottom, big bottom, talk about my bum cakes, my girls got them. Big bottom driving me out of my mind. How could I leave this behind? Yeah, I heard that song in my head as soon as he said it too. Medialot says, so I'm on top of the world, not the bottom. Australian for the win. There you go. Hold on. Nomad Universe says, can you please unblock me so I can block Dick Wayne. He's made yet another account. You can block as a moderator, you can block him, right? Dick Wayne gets one account that is his account to use on here. And currently he doesn't have a wrench, though he's emailed me today and he wants it back. We're in negotiation. So you can block him. You can, right? Being a moderator, you should be able to just play whack-a-troll, right? But now, if he does say something that's not super dumb, let it through a little bit. We need a little coming through. The Unquirer says for $10, very nice, thank you. Flat Earth is akin to not requiring proof of U.S. citizenship to vote. We know this well in Maine because we have an honor system where a goat can vote and no one can question it. Oh my gosh. Mods can only block other mods. Oh, all right. Well, hey, if you don't want the wrench, there you go. You can have it back. Just let me know when you want it back. Hakraman says, rather listen to insane TikTokers than this knob. Yeah. That's why I just like, yep. Thank you for that, Kango44. We got Hakraman says PhD Tony is going to do some bitch slapping. Woo! I'm going to get back to here if he's doing it. Hold on, let's hear.
Assumptions about whatever. Don't say something that is stupid, like they admit to modifying the environment when they did nothing to the environment. They did nothing. Nothing was done to the environment. You are misspeaking, and you need to actually be clear about what you're saying. They are plugging numbers into their models that you claim are not observationally validated, right?
They are mathematically, on paper, making a modification just in a mathematical sense. They are skewing the environment mathematically. Now, is it they're going out and seeing clouds or whatever? No, that's not what I'm saying. I am saying they are mathematically on paper making skews, and you can't say no to that because that is what I'm claiming.
Okay, but that has nothing to do with changing the environment or manipulating the environment.
On paper.
That is making mathematical assumptions about the values that plug into their formula. That has nothing to do with manipulating the environment. And please, when you are trying to say something, use the appropriate words to describe it. Manipulating the environment is not what was being done.
Okay, listen, this is what Byatt said. I'm going to say it because he uses this, because I'm saying they're modifying the environment, and this is his language. Okay, this complete generality in the formation of differential equations and in their numerical resolution is perhaps today the only improvement that the great geometers mentioned above have left us to introduce into the theory of astronomical refractions. For nothing can be added to the beauty or rigor of the analytical methods they use to integrate the differential equations specific to the atmospheric conditions they accepted. Okay, it was the ones they accepted, meaning they are imposing atmospheric.
Okay, we don't really need to hear what he says too much. He's like, the differential equations, this, and that they're doing, right? None of this is going to result in, therefore, the refractive conditions match flat Earth. Never will that happen. That never happens. Never, right? It's so extreme. Bending the other direction, and a whole bunch of other effects would happen. This was seriously 8 years ago on the Flat Earth Society forums. All of this upward refraction stuff was talked about there, was proposed there. And of course, they had a different magical cause for it. And there's all sorts of other problems that you would have if light bent up all the time. I won't cover that right now. Maybe that's a good thing to talk about at some point. Truth Nerd says PG Tony means beam divergence, not beam dispersion. Yeah, and they were using two different words, weren't they? Tim Davis says, if a flurf makes a strawman argument using ChatGPT, can it be called a strawberry? If you know, you know. That's right. LLMs miscounted the number of R's in strawberry. They would typically say 2, even though there's 3. Here's what I find funny. Flat earthers love to go to AIs to get answers to things that agree with them. Right? And I say, go ask it what shape the earth is. Like, well, I don't accept that. Okay. You don't accept ChatGPT as an authority then. Neither do I. Neither of us accept ChatGPT as an authority. So we don't use ChatGPT as an authority. We don't go ask it a question and then use its answer as evidence or as anything in a debate. If you want evidence, you got to go to evidence. A ChatGPT isn't evidence. Nomad Universe says, here, I got this. Hold on, let me see. This should work now. There we go. Nomad Universe says, if you talk to Jesus, that's fine. If Jesus talks to you, it's time to get a carbon monoxide meter. Thank you for that, Nomad Universe. Icy Spin says 4 out of 5 high probability eruption alert. Alert. Let's hear.
Only occur, primarily occur if there is a significant flux of vapor into those lower areas. That's what he's saying, right?
Actually, he's saying both of these are not possible. That's what he's saying. He's saying both of these things. I'm a stupid flat earther, right? And I'm just
okay. Does he say that both of these assumptions introduce always or often introduce large errors? Does he say that?
Yes, he's saying they are not integratable.
That was not my question. My question was
that graphic by who was it? Apocryphon says 21 viewers. There's 414 of you right now. Thank you so much. You guys are awesome.
Use the environment to account for refractions. So if you want to say that, he didn't strictly say it. He does say that we cannot rigorously apply humidity the way that we measure it. That's why he's saying we cannot do this in a rigorous manner. Those are his words. Because if we do, it doesn't work. So we have to use generalities. Okay? And that's what he said was the last thing.
Does he say that using those generalities introduces large errors?
They have to use them because otherwise it doesn't work.
Does he say that using the generalities
he won't answer the question.
Introduces large errors? Does he say that?
I am not going to say what you want to say because
he won't.
He does not say.
He does not
that
say
introducing these generalities introduces large errors.
He does say that unless we use it, he does say unless we use these generalities, the error is so big we can't account for it. That's what he's saying. He's saying if we use rigorous values, we can't account for it because we have to use the generalities to account for it. It is an implication that there is a huge error.
Oh my goodness. Arwen, what does it do to you when you hear this guy talking?
It literally makes my dick go soft.
Dude, Arwen. Woo. I don't know if anybody wanted to hear that. That was because Icy Spin sent me this. Oh, what happened? It didn't show it. Oh, it did show it. Why it not see? Maybe it's, it didn't go back to the right. Hold on a second. There it is. It went to the wrong one. There it is. Arwen describes this conversation in a DM, says Icy Spin. Thank you for that. Tad is mad says for $2, brains so smooth you could ice skate on them. Oh yeah. So I made this bigger. Is that nice? You like it? Is that a good change? This is a test. I need to do a little more work, but this is probably what I'll wind up doing. Black Sabbath 2724 for $5 says if you put pathological liar into your GPS, it will take you to Lanolin's house. Oh snap! Oh snap! All right.
Large errors. That is exactly what he says in the textbook, and this is why your ability to correctly interpret scientific literature has been in question from the very start.
I get
because
it. Because
the very quote that you introduced, look, mate, you've got to talk for fucking hours on here, uninterrupted.
Why are you crying?
The least you can do is extend the courtesy to me to allow me to talk. I'm not crying. Thank you for asking.
And it sounds like
the idea. Well, then you need your hearing checked. Then you just introduced a quote from this textbook that you are citing, and the quote directly contradicts your interpretation of the quote.
Here's the quote.
This is the point. This is the point. Again, you are interrupting me at the point rather than letting me finish. Shut up. You will get a turn, I promise. The question here is whether or not you can correctly and properly interpret the text that you are reading from. Again, based on this evidence, we have direct contradiction of your ability to properly interpret scientific literature.
We have the worst evidence, but here we go. But we can thus clear. I'm going to quote him right here because I'm telling you,
they do have the worst evidence. Flatties do.
He's not saying it makes it more accurate. This is what he's saying. But we can thus clearly recognize what the refractions calculated by the current tables assume to be particular to the state of the air. Whether these assumptions can physically subsist in.
Oh my gosh! None of that will make flat Earth work. None of that will make refraction do anything that matches flat Earth. Oh, jeez. Spherical Earth Propaganda Bureau has a 38-month member super chat. This is thanks for the entertainment. Well, thank you very much. Let me see what it looks like when I do this. There it is. It says Newton. You see, it doesn't get the message on there. I need to code this up a little better here. So it actually puts the message there instead of just the level of membership. So little fixie to do. I had some. I was gonna work on it last night. I you know what? There's that interview on Joe Rogan. Oh my gosh, it's terrible. The guy, total flat earther. The guy that was worked with Quentin Tarantino on Pulp Fiction. Friends with Quentin. Guy's 100% flat earther. And I figure out in the analysis, I figure out who his Papa Flurf is. I have the script written. I'm hopefully going to record that really soon and have it out as soon as I can, analyzing that. It was nuts. The guy is dumb. So dumb. But, you know, he's a movie producer. He's not a scientist. But he thinks he's a scientist. They're so dumb, people.
And I let you speak, and then I let you finish, and now you're interrupting me. Shut the fuck up, you rude.
I'm using such poor language.
Because you're being so rude. So if you were being polite to me, I would be polite to you. But you're being a fuckwit,
right?
And so I'm going to call you a fuckwit.
Getting the crackatoni.
So let's get back to the topic. My ability to correctly interpret scientific literature and what mathematicians are saying has been assessed, right? Yours has not. The two of us have different interpretations of the text that you are reading.
I have college
papers of the two of us, my interpretation is the one that the audience should have more confidence in, because my ability to assess this literature, to comprehend this literature, has been.
Hold on. I got to ask again. Arwen, what does this do to you?
It literally makes my dick go soft.
That's for Icy Spin.
Because you've got people who are trained in interpreting scientific literature who are telling you are just mistaken.
Tony, I have spoken with a military land surveyor who was a lieutenant at my communion hall, and I asked him the questions. At 10 miles, am I going to be able to see my laser at 10.3 miles if we're both at the surface? And he said, nope, the Earth curvature would get in the way. I asked him how much Earth curvature would be there. He's the only guy in the world that I've ever met that isn't like talking on Discord or whatever on the internet scene. And he was like, well, that'd be probably about 60 something feet of curvature at that distance, just ballparking it off my head. And I was like, great. But the thing was, I had already done the observation. So I was like, so I already did that observation. I could see it. And he's like, well, then maybe refraction would have something to do with that, where you might be able to see it or whatever. And I was like, well, I actually accounted for that using standard refraction, and I still couldn't see it because at that time we didn't take those measurements as to what was going on, and we didn't measure it. So I actually did query a military land surveyor who does have the quote-unquote accreditations that you're seeking for, and he didn't even think we'd be able to see it at 10.3 miles. So, I mean, yes, I have spoken with other people. He's not the only guy.
So you're idiotic. This is how idiotic that answer is.
No, I'm just telling you, I have consulted other people.
I asked you, have you had your interpretation of this literature assessed by a subject matter expert? And you tell a story about going to talk to somebody else about your laser experiment.
Yeah,
that was not what my comment was. That's not what I asked. You are simply incapable of properly interpreting the English language when it is spoken to you. You need to have your understanding of the literature assessed by subject matter experts.
Tony, if you want, I will send you my papers on the assessment that the college did of my writing ability, and I assure you,
waste my time.
They will be much higher.
Submit them to a surveying. Submit them to a surveying journal.
I'm just saying, like, dude, if you want to just attack my character all night long because it's all you've done,
rather than the material.
Attacking your character, calling you ignorant is not a character assassination. Calling you ignorant.
Let's put a timer and see how long it takes before Tony addresses the information.
No, Tony, I mean, I'm not yelling at you. I'm really not. I've raised my voice a few times, but...
You have, and you have interrupted me incessantly, and you have fired me up. I'm not somebody that it's that hard to make angry. And you have made me angry with your intellectually dishonest responses, your continual interruptions,
Let's be honest, it's easy to get Tony angry.
Fundamental misunderstandings when I explain things to you.
Succinct.
Where you explain things. Who the hell are you?
Succinct.
All you say is no.
DMOC. DMOC enters the arena.
Paper don't help you tell the shape of something you're on, idiots. Neither does the word data.
I'm a stupid flat
Maybe
earther,
try fucking
right?
with the
And
thing
I'm just
that
a
you're
loser.
on. Yeah,
now the chaos reigns.
You can't go find an earth curve in your front yard, MCToon. How about this $10,000 out there on the earth curve, on the fucking real earth curve, physical dirt one? You can go touch it. There's $10,000 waiting for you, weirdo.
In the lab, can we get a bucket
Isn't that funny? Earth curve doesn't exist.
You're funny.
Oh
my gosh, you are
There's 100,000 waiting on the earth curve for you. Go touch it. It's in your backyard, the earth curve.
In the lab, can we get a bucket of In the lab, can we get a bucket
Which
of
clover has the earth curve in their yard? They can go out and fucking trace right now.
The soundboards ruin everything. You gotta stop the soundboards.
Right now. Or knows what 8 inches is from a horizontal line. A drop away. Which
So, I
clover
have a question.
runs the elevation tool in a horizontal line? Which one doesn't run the elevation tool?
This might be a good spot to
elevation.
Yeah. So
I
you
know,
explained this to me the other day
retarded
too.
motherfucker.
I get you. I know.
Elevation tool.
Um,
Like
a
not not
like an
Bible
elevationometer.
data, not data from
I
a
mean, an
Bible. It's an
elevationometer.
elevation tool. Can you use that
Right,
tool to show drop on the tool, right above the tool or below the tool?
Hey, well, thanks for having me, guys. I'm
You
gonna
got a
take off.
horizontal
No,
line
have fun.
waiting.
Later,
You got a
Sheeps Wolf.
horizontal line
Thank
waiting.
you,
You got a
Yeah,
3
love
foot
being here.
horizontal
Good
line
talking
waiting
with
to show drop anywhere.
Peace out,
You got a
y'all.
horizontal level line waiting. Now you got an altimeter. Show that rise. Show that
All
rise
right.
in
All
elevation
right.
along that horizontal.
Explain the experimental setup again. Back up for us. I want to know what you're proposing.
Hold on.
All right.
Horizontal line that doesn't raise in elevation.
Describe the apparatus that you're using.
Do you have any globe proof on how globe elevation works? I've got flat Earth elevation right along a horizontal. Unless you
can you show them?
Do something different.
Can you show them? Do you like have video of it or something?
I got a horizontal line here, fucktard. Where's your Earth curve, retard fuck?
Could you show it, please?
Horizontal line, that's for sure. Droppity drop drop.
You said you had it. I want to. Can you show it?
Put the fucking altimeter out in your Earth curve and let's line it up against my horizontal.
Can we get a
Let's
bucket
see
of
the
LeBron?
8-inch drop.
Hold on. Can you show me? Can you Oh my gosh! Just a second.
Stop fucking talking about can we do anything but not physical fucking Earth curve. I got a horizontal line. Are you going to draw your Earth curve underneath it?
He's got a clarifying question, and then we can move forward.
We're going to see what elevation follows.
All right, go ahead with your clarification.
Okay, so Demok, you said you had an example of this that you had done. Of something about elevation. It's hard to, you kind of ramble a bit and it's hard to kind of pick out what you're talking, but I'd like to see that example that you were talking about that you had.
Horizontal elevation tool.
Yeah, show it. Do you have video or picture of it or something?
The 3 foot horizontal is still 3 foot high level everywhere.
Could you show it?
If I make the 3 foot line 1,000 miles long, you retarded fuck. This altimeter is not going to change.
Did you do that?
Show me where it is.
Just
show me where it's going to change. You dumb cunt.
You said you could do that.
So
yeah. Let's see it.
Change along a horizontal.
I just want to see it.
I'll bet my money it doesn't.
Could you just show? Yeah, just show it. You said
a level horizontal line. You'll never see a drop.
But Demok, you don't.
Are you talking about a horizontal line in reality, though, Demok? That's one of your requirements.
We don't care about your fucking dream retard religion.
Did you do that in reality?
Horizontal line that actually exists, retard.
Where?
And then what you'll need to do?
Where is it?
Fuck.
Yeah, I don't know where it is.
No. Get the elevation tool you don't trust. Now you don't trust it. Now you don't.
But it exists in reality. So
I don't
have an Earth curve.
I don't know if I should trust it or not. I just want to see it.
On the wall. You can't put your what equivalating on the wall.
What equivalating?
You fucking retards. What does it look like up close?
Up close, it looks like a
What does it read on the altimeter versus the horizontal line?
It looks like a manifold up close.
On the elevation tool along a horizontal.
Now that's 3 questions in 9 seconds. Go ahead, Tim.
Yeah. All right. So you said, what does a Earth curve look like up close? It looks like a manifold. Okay. What was the next question? Do you remember, Spin?
My horizontal line is placed at the end, horizontally, stabbed horizontally into the water.
Stabbed horizontally into the water.
Where you are.
Okay. How does it? No, hold on. Pause for a second. Pause for a second. Okay, so hold on, no, you gotta wait. So if you stab the altimeter into the water, is that what he's doing, Spin?
No, I want to make sure. Have a horizontal line for the altimeter.
I'm gonna try to stay out. I don't want to argue and mod, so I'm gonna step back and
just trying to get the clarification. Yeah. This experimental setup sounds amazing.
Right, you're taking the deck of cards and you're slinging all the cards at every person in the restaurant. So like slow down for a sec, try to reset. Let's get a good take on like where we're headed with this argument, because I want it to play out and be productive. Go ahead.
All right, what was it that you're
understand what elevation is? I don't know what you don't understand about change in elevation or change of rate. Or change the rate of slope.
I can explain it.
Slope along a horizontal.
I can explain.
Okay.
I can explain.
Okay to think
I can explain. Okay, so all right, so on the globe, horizontal diverges from the surface of the Earth or diverges from the level. Level is a curve on the surface of the Earth. So there is a slope on a horizontal if you use that, if you pin a horizontal to one spot and then you continue on that horizontal away from that spot, it's going to slope. But there is no slope for level, because level is a curve, and so that level is a consistent elevation above a datum, which on the globe is WGS84 is one of the datums you could use, which is an ellipsoid, nearly a sphere. And so a change in your distance from the surface of that curve is a change in elevation. Okay, go ahead, Demok.
The horizontal line is not a curve. I don't know what kind of crack you've been smoking, retard.
You're right. The horizontal line is not a curve.
The horizontal line has never been a part of a curve ever.
That's right. I agree.
Cubes don't exist on a curve. If you set a cube on a curve, the corners are going to levitate.
Yeah, you're right.
A cube, you fucking retard. Got it. Go get a ball. This is reality, bitch. Stop running.
Got it.
Go get a fucking cube. right, with sharp corners, and then go get a sphere, a smooth one.
Yeah.
Set the fucking cube on there and let's zoom in.
Okay. Then what?
You need to find a cube that lines up on there without corners levitating.
Oh. So in reality, hold on, just a second. I want to talk. Pause for a second.
Yeah,
pause.
Pause.
Pause. Okay, so you want somebody to get a cube that is like maybe a third of the size of the globe, and then place it on the surface of the Earth, and then see if the corners come up off of it. Well, that's a little bit of a big structure to build. I don't think that anybody I know of is going to have the budget for that. So maybe you could propose an experiment that's a little more reasonable.
Yeah, it's called get a cube and a sphere, you dumb cunt. You think you live on a sphere, you stupid bitch.
I'm not the dumb one here. I'm not the dumb one here.
If you think you live on a sphere, you fucking retard. You don't have any fear that you...
Hold on. So,
in a lab, can we get a bucket of Lagrange?
I want to progress the conversation forward. So, you're going back to a cube and a sphere. Let's talk about maybe dimensions, or maybe how they would be set up in a room together or in a lab. Let's move it forward a little bit. Let's make some progress. Try to see if we can wrap our minds around what we're talking about. Go ahead.
You guys don't like progress. You're dumb cunts. You don't trust spheres and you don't trust cubes. You only trust.
Okay, so I'm literally asking for us to make some progress, and the only way I can achieve that, or the room can achieve that, or the conversation can achieve that, is if you will work with us and try to make progress yourself. I'm just asking you to do it. I can't do it for you. So go ahead.
Yeah. A ball doesn't need no fucking helpers, retarded cunts. It doesn't tell secrets. It doesn't lie. It doesn't make shit up. You fucking retards do. A cube doesn't lie and make shit up. You fucking retards do.
All right. Well, how is this going to actually be tested?
Go in a class, get your sphere, bitch, and go get the one that follows your claim, ho.
Nobody's ever paid me for that service. So thanks for the vote of confidence that you might think I'd get paid for it, but I have not ever actually gotten paid for it. Well, sorry, Spin, go ahead.
Yeah. We're not going to make I'm going to leave him on mute for just a little bit. Maybe he can take a breather, finish eating his bucket of Lagrange chicken there, and then maybe we can make some progress. But does anyone else want to engage? APOC, are you still in the room? I thought I saw you.
OG. Oh, he's not there.
OG. Yeah.
Oh. I see. Taking back Eden is there. Yeah. He's funny.
Yeah. Sorry.
What's up, bro?
Oh yeah. I just want to say thank you for your time, Mr. MCToon. Sorry, I think that's how you'd prefer if I call you. And sorry if I'm wrong about the flat Earth and all that good stuff. And thank you for your patience.
Okay. All right.
Well, it's funny you did say Mr. MCToon, and that's it's actually wrong, but I know you're trying, but it's MCToon is what it goes by.
Or just Mike, or just Tune. But it is how flat earthers tend to self-identify.
Sorry.
So yeah.
Yeah, my apologies. Oh man. Yeah.
I love this. The dangers of marijuana. Beds should look like beds. I ordered this when I was high because I thought it was a giant ice cream sandwich. It's not. It's a bed and not the $150 ice cream sandwich I wanted.
It's so funny, Black Sabbath.
Oh my gosh. Oh, it's hilarious. Is Gatekeeper
Mod Kitty might have engaged.
Is Gatekeeper a concaver?
I think it used to be, right? Gatekeeper
used to be a concaver.
Yeah, he seems to be fighting the good fight.
Okay, that's good. A lot of the time, for some reason, like the concavers like to use like the Gatekeeper like claim. They lean into that a bit, but there's like all of like 7 concavers, so I kind of got a soft spot for the concavers.
Yeah. Mod Kitty, do you have anything on your mind? I know I think you engaged a little bit last time, and we were talking before about Mage 2, I think, and I don't know, maybe
yeah,
something's on your mind.
You gotta send me some super chats first.
Oh, okay.
I gotta send you super chats. Was that Mod Kitty?
He's actually running the Q up live stream. So
that's nice.
Appreciates that. And
I don't imagine that's hold on. I don't think QOp's stream is or channel is monetized yet, though, is it?
No, not yet.
Yeah, okay. Well, so there you go. People here, you're gonna have to send a super chat from YouTube over to Mod Kitty somehow. I don't know how, but that'd be great.
Well, I'll ask you. I mean, what was we engaged like? It was late at night, but we were talking about Mage 2, and I showed you a lot of aerial photographs, and we went through them. And remind me, I don't want to straw man you, but I think your argument was not at the end of it.
That's a common one.
My only argument against Glovers is you don't have direct measurement of Earth curvature. That's it.
Oh, and you know what flat earthers don't have?
You need a ruler. You need a ruler, a really long ruler for that.
Flat earthers don't have direct measurement of Earth flatiture, so it's the same thing. If that's what you have. So how was it? This is my question then. How was it that, since that's your standard of evidence, that you became a flat earther? All right.
Yeah, I don't know how to answer that. So
yeah, it's called a double standard, right? You became a flat earther with very, very little, basically no standard of evidence at all. You just took whatever somebody said. But in order, to accept any evidence from Glober as well, you need a extremely high standard of evidence for all those things. You need a direct measurement, whatever you define as a direct measurement, which you probably, when pressed, wouldn't actually be able to define. But you need a direct measurement of Earth curvature in order to accept it. But you didn't need that for flat. So Henry Ford is held down, forced to watch in horror.
Every empirical observation points that we're not rotating or moving through the galaxy. So globe is
okay. Well, then should I provide you some, you'll accept them?
I'm a stupid flat earther, right? And I'm just a loser.
Right. If I provide you some empirical measurements of the motion, you'll accept them?
I mean, the only thing that he could accept is probably a ring laser gyroscope, and even that he would probably not understand how it works.
In a lab, can we get a bucket of LeBron?
So that's the thing. That's the thing, it's back to the standard of evidence. What type of evidence would you expect and would you accept as measurements of movement of Earth? What would you expect and accept?
The silence of concession.
Who the fuck you talking to, homie?
Oh, how about feeling movement would be
okay. What part of the human what part of the human anatomy feels constant linear velocity?
I don't know.
Well, the answer is there is no part of the human anatomy that can feel constant linear velocity. So there is no way, we don't have the equipment installed in our bodies to feel that motion which you expect to feel. So now we go back to the first question. What would you expect and accept as a measurement of the motion of the Earth?
Well, hold on. Before we completely finish with the first point you just rebutted with, are we in a constant linear trajectory?
We are not. That's a good point. Would you want to explain where you're going with that? I think you're on the right track though.
Oh yeah, thank you. So essentially, if I'm not mistaken, we would be falling around in orbit, and it's continually accelerating, or there's an increase of acceleration and a decrease of acceleration. I think some people would argue that.
So yeah,
it would be times. Yeah.
I can explain that. So on the surface of Earth, the motion of the Earth as the motion of a globe as it rotates daily would cause an primarily upward vector that would be rather small. So on a globe that is rotating at 6,371, a radius of 6,371 kilometers, going once every 24 hours around would have an upward acceleration at the equator of 0.03 meters per second squared. Now, we don't have that ability to feel that amount of a differentiation from one point of the surface of the Earth to another, because that would vary, because at the poles that would be zero. But we lack the ability to distinguish that within our anatomy. So there would need to be something else that would be more precise than human anatomy to measure that, like an accelerometer that's that precise. That's number one. Number two, as the Earth orbits the sun, it orbits at different distances from the sun, and so the centrifugal acceleration is different at those times. That's the acceleration. But the centripetal acceleration toward the center of the orbit is also increased, because at the time when the centrifugal acceleration is increased, it is where it is closer to the center of mass of the orbiting system. So it has an increased centripetal acceleration. So they actually cancel. So we can't feel that in our bodies, and there isn't an instrument that can measure that, because they are canceled. So neither of those would be something that we would feel. Does that make sense?
Yeah.
Eden?
What about any visual? I know we have the Himawari. What about amateur? Is it even worth setting aside amateur money for amateur visual for Earth's rotation?
Well, amateurs can do it from the surface by looking at stars. But are you talking about amateurs moving outside of the Earth to view it?
Yeah, maybe.
So like a non-government agency, maybe?
Yeah. So if let's say we had $20 million for 4 rockets, and then we just had
20 million won't get you 4
rockets.
20 million won't even get you a seat on a rocket.
No. Just the unmanned rockets with cameras.
Oh.
And then that way we can capture. We'll have to hire some scientists who specialize in, I guess, orbital mechanics and some rocket science, and we can determine what trajectory that we could capture.
How far out do you think? How far out would you accept as a motion, right? Because if you're near the Earth, you're going to have to be in orbit around the Earth, and that orbit is motion. So it's going to be difficult to distinguish the motion of the orbit from the motion of the Earth in a quick way, right? You could measure it, but in a quick way, it'd be difficult to measure. So you need to I think you'd want to get farther away, right?
Yeah, definitely. But yeah. So great point. It gets expensive.
Yeah, I'd say an ideal location to watch the Earth move would be Lagrange 1, which would be a spot between the Earth and the Sun, and that's a gravitationally neutral zone. Essentially, you can park something there and it's in equilibrium, and then you can watch the Earth move. Now there are things there, and you can watch the Earth rotate from those positions, but you want an amateur to do it. You probably are going to need a lot more than $20 million today. Now maybe as space exploration gets more consumerized, that might be possible. SpaceX has, they're not a government agency, and they have they've done a lot of the things, a lot of the launches themselves. So I don't know if they've put anything at L1.
It's not called Space Doge anymore, or was it? It should be called Space Doge, right? No.
That was quite a few years ago.
Space Force, you mean?
No, Space Doge.
Doge.
Because Elon was talking about Dogecoin.
Yeah. We used to watch the Earth pretty much rotate. Me and my sister in Hawaii, we were like, I don't know, like 9, and she was like 7, and we just lay on the beach, a bunch of friends, and we just watch the stars move. We just watch them go to the horizon and disappear. And that's a way of watching the planet.
Yeah. And to be, if you don't have any other information, you couldn't, in isolation, you couldn't distinguish that from the globe being stationary and the stars orbiting around him, until, you need to do a little bit more math. You say, well, the centrifugal acceleration of stars moving around the Earth like that would be incredibly massive, and so they'd need to have a large centripetal acceleration, and there is nothing that explains that. So that's a challenge.
Is that what stellar aberration is? Like when all the stars would have to be on the same plane if they were up there, but you got stars that are further away and closer and stuff, like they would look different as they rotate if it was that moving, I think, right? Or would it not?
No, aberration is a shift in the position of the stars based on where they are in the sky. So and it's because the Earth is moving and light has a finite speed, and so that the aberration is a composition of Earth's speed in relation to the speed of light. And so it's a small amount, because the speed of Earth compared to the speed of light is a small ratio, but it is a measurable amount, about 20 arc seconds. So stars that are in the celestial poles move in a circle. Stars that are on the celestial equator, I think I'm getting this right, yeah. Celestial equator just have a 20 arc second wide line, and everywhere in between has an ellipse of varying radii.
Doesn't an equatorial mount also show that we're rotating?
Yeah. Well, an equatorial mount shows that, 1, the Earth is a globe, and number 2, something is rotating.
Yeah.
Again, in isolation, you without considering centrifugal acceleration, centripetal acceleration, right? But yeah, there's I think this is Wolfie's Wolfie 6020's. Let me bigify that guy. Wolfie 6020's telescope on an EQ mount, and you can see it's tracking. I don't know what it was tracking. I think a star or something, but you can see it's pointing down, right? And it's only rotating on one axis. That's the cool thing about it when you really get to understand what an EQ mount is doing.
Wow.
Yeah, have you ever tried following? Me and my daughter were trying to follow Saturn, but we only had I had to use my, it wasn't mechanical. It was just me rotating one dial and the other one with my other hand trying to follow it. It took me about 5 minutes to actually get the groove down, to where I can do it. And I'm like, okay, I have my daughter look now. And I'm like, hopefully I have it.
Yeah, I have a P1000, and a couple times I've got the transit of the ISS in front of the sun and moon, 3 times total. And you can't just point it at the moon or sun and just wait there. You're constantly moving it. So you're being really, when you're doing it, it's tough because you're looking at the time and you're saying, okay, when the ISS is just about to cross, I need to make sure it's right in the spot. But of course you're moving it and it jiggles all around, and you don't want your money to jingle jangle. You got to fold it.
Yes. Well, in Florida, that was a problem. In Florida, everything jingle jangles because it's all floating. It seems like there's always a vibration there. Like I can pan it a lot better up north.
Okay.
When can you film it
it's
from
all
5
floating.
miles high?
So that's
What's that?
Prove it's above 5 miles by going 5 miles and filming it from that location. Film it directly above you, flying above you. The magical, non-existent ISS distance. They can't be proven in reality unless you're on the ground. You just got to be on the ground and prove it. Can't be 5 miles, 10 miles.
I don't know what you're talking about.
Where else? Just on the ground. Isn't that weird?
Something's weird. Something's definitely weird,
Cameras
D-Mock.
don't exist on the top of an airplane, said MCToon. His 57 cameras he could put on top of the airplane or hot air balloon or helicopter or telescope he could take and zoom up at it. He can't
Then
zoom
what?
up now.
Then what?
Now his telescope don't
Wait,
see
hold
in
on
the
a second.
face.
Hold on a second. I have a question. I have a question.
A couple miles above his
Hold
head.
on. Pause. So, do you want somebody to put a telescope on top of an airplane to get the transit of the ISS in front of the sun or moon? What would this? What's the hypothesis for this experiment?
It's called The Loser Who Could Prove the ISS is Above 5 Miles High.
Oh, that's to test whether
camera and you get a loser, right? One that's not retarded, and you get your telescope. Stop making excuses why you can't film upward, you fucking retard.
Okay, hold on.
Telescope.
Pause.
So your telescope can't look up from the plane.
Pause.
Can't look up from the train.
Pause. Okay. So the way that, I mean, there's a couple ways to do.
Flat earther, right? And I'm just a loser.
Yeah, D-Mock. Okay. So there's a few ways to do that. One is you could look at the actual the way that the position of the ISS is computed, and it's computed in 3-dimensional space. But I know that's probably a bit above your head. Anyway, if it is your claim that the ISS is somehow less than 5 miles high, amazing that something can move that fast, then that would be, you have the burden of proof, not me. All right, go ahead.
The word that fast didn't mean anything, you fucking reject. Neither did the word that high. Now, if your airplane is at 5 miles, you stupid bitch, to prove it's above that, what would you need to do?
I don't know. It's on you. It's what would you need to do?
We don't care about your hope.
You are the one that has the burden, not me.
Dr. Seuss shit hot air bag.
This is
you have to build a machine.
You have the burden. You have the burden, not me.
A machine that could withstand that kind of like particles hitting it.
Spend $5 on a camera. You fucking reject low IQ fuck. And film it upwards.
No.
Have you ever been on a motorcycle and you've been flying like 150 miles an hour? Like, you know, the resistance? The resistance is so much.
No, it could be done. It could be done. But
cameras now.
But it's
now they don't trust airplanes.
All right, D-Mock, hold on. Shh. So the conundrum here is that, D-Mock, you have the burden of proof, not me. You're the one that is saying that contrary to all the other evidence, that the ISS is for some reason only 5 miles up. So I don't have the burden of proof. You can demand all day long, and all you do is make yourself look desperate. And I love when you do that, because it really does show how flat earthers aren't interested in truth. They're only interested in rhetoric. All right, go ahead.
Speaking of Red's rhetoric, remember Red's rhetoric?
Hold on sorry, Democ. 1 second. Was that Tony that was talking? I missed that. Let Democ respond. Go ahead, Democ. Let's try to move the conversation, okay?
Yeah, you schizophrenic son of a bitch. Stop saying what you do. I said get a physical motherfucking camera or telescope with your physical ass on there, and fucking when the ISS goes above by your mathematical magic, you fucking retard, on your real airplane with a real camera, you stupid bitch, at a real 5 mile high, you can get it. You got the rhetoric, cunt. The nothing burger.
Is that a rap song? I think I heard that in a rap song.
Yeah, it could be.
That's the hottest fire I've ever heard.
Yeah. All right. Well, here I'll link in the chat there for you, DMOC, the burden of proof reversal. All right. You said the burden of proof lies not with the person making the claim, but with someone else did the proof. You made the claim. I don't have anything to do to support your claim or to refute your claim. You do, not me. So proceed with it.
One sec, Toon. Okay. I'll let you finish, Toon. Democ, just let him finish. All right. We'll be going back and forth. Let him finish. Then you can rebut. Then you can go, and then he can go, and then you can go. Let's keep it like that. Don't interrupt him. Don't cut him off to make a point because it's just going to go unheard. And I'm going to have to keep pressing server mute, and I don't like doing that. I'm going to leave you off mute for a minute. Just let Toon talk through it, and then you can respond. Go ahead, Toon.
No, I'm good. DMOC, go ahead.
Okay. Go ahead, DMOC.
He simply hates reality. No cameras work for him. Being at 5 miles high doesn't work for him. And then his whole story, when I came in the room, he was talking about ISS and what you could see from it. And that's all they do is talk out their fucking ass about a magical ISS that's at a magical height and how they can tell the speed and the height. Then he says the burden's not on him.
Yep.
I didn't make that shit up about a magic dragon ISS being at a magical fucking Jesus height. You did, weirdo. You and your fucking religious height, depths, and distances.
Okay.
Now, can you prove it with real fucking heights and distances, you fucking retard?
All right.
Gotcha.
All right. So, good point there. The height of the ISS can be confirmed in a couple ways. Of course, you can look at the photos and videos that people have taken from it. There's over 600 people that have been in it. But if you want to do it yourself, you can do the same technique that Res Rhetoric and Astronomy Live did, where they were at different positions on the surface of the Earth apart from each other, and they measured the parallax of the moon, and they not the moon, the parallax of the ISS in front of the moon. So they both recorded the ISS transiting the moon at the same time, and then they waited for the moon to move, because it moves at 15 degrees an hour, in order to then get a reference to where all the stars were. And then they were able to compare the positions of the stars in relation to the ISS from those two positions, applying parallax. Now, this doesn't assume the distance of the moon. It doesn't assume the size of the moon. It only
Where's the distance ruler then?
It only uses. Hold on. It only uses. Hold on.
Holding on for
Hold
this
on.
is the whole point here.
Hold on.
You said you've got
Pause. Okay. And so it uses the parallax. So I explain how it's done. I'll get you the video. I know you won't be able to respond at the moment. I'll grab the video, and all of the data is linked in the description of the video, and you can go look and analyze the math yourself at your leisure.
They were only like 5 miles away from each other, I think, if I remember.
Yeah.
I was in Florida at that time.
Yep.
Yeah, I remember that. That was good. That was really good, actually.
All right, go ahead, Demo.
They had a lot of magic going that night.
Maybe I'm trying to figure out how we can take this conversation forward. There's a disagreement on.
We don't have any distances. Everything he said is garbage. La La Land. From fucking Narnia.
Okay.
Where is
Give me 1 second. I'm going to ask.
250 miles. Where's the ruler that tells you 24,000 miles? Where's any of his distances on a physical fucking material that the retard can fucking back? Don't have it.
Okay, maybe.
Don't got 93 million. Stop saying okay, you dick riding bitch.
Let me try to push this forward because you and Red's rhetoric had. Hold on a second.
That he's claiming he knows with parallax.
We're circling the drain on that one.
Fucking
all right. Listen, Dimmock, you had this conversation with Red's rhetoric last night, and you had a disagreement about parallax being a measurement. Maybe that's something that you could sort of flush out with why that doesn't work, because Toon brought it up. And you seem to go back to, you want a physical string. I think you mentioned a plane and pointing it up. And it's a little bit vague, right, for us to actually take it seriously as an experiment. And I really do want to move the conversation forward instead of us kind of keep repeating the same thing over and over. Maybe you can help kind of work out or just kind of play out what you think an experiment like this might look like and why it would be relevant and why someone should take it seriously. And I'm not saying that tongue in cheek. I'm being serious. Let's try to like get on some sort of trajectory with the conversation. Go ahead.
Yeah, you and him looking at each other's dick and making up how big they are doesn't help you, retard.
It's parallax still.
Yeah, you're fucking retarded.
Yeah. So could you address the topic? Yeah.
Thorlax and Thorlax.
Could you address the topic?
Okay.
Do you have a motherfucking real distance?
Could you
I'm gonna put him on mute for a little bit.
Yeah. All right. Obviously, he is disinterested in addressing the topic. So let's review what he's done. He's demanded a measurement to the ISS. I provided a measurement to the ISS. He has basically declared that he won't even be looking at this measurement to the ISS. So this is flat Earth, people. This is flat Earth. They demand something, it's given to them, they refuse to look. Flat Earthers are not interested in truth. They are 100% committed to the deception of flat Earth. And DMOC is one of the best people that demonstrate this. So,
well, can I just be on? Okay, because I'm a Glober too, but I mean, flat Earth. Okay, yes, you're right. A lot of them like deception and stuff, but DMOC's like the extreme. You know, I mean, like,
yep.
When it comes to flat Earth, yes, a lot of them get blinded, and I think there's a point to where, well, I don't want to really say what I think people are thinking, but it kind of seems like that though. Like they think they know the answers, and it doesn't seem to ever be right. And this whole parallax thing he's talking about, like, what else is parallax? It's a parallax itself is a measurement. You know, it's like,
yeah, parallax is a technique. It's just geometry that can be used to measure things. It's accurate. If somebody disagrees with parallax, then they could go show how parallax doesn't work, but they're not going to do that because parallax works. It's been a basic part of geometry for millennia. So the flat earthers then who disagree with the results of this would then have the burden to go through and show where it's wrong, show where there was an error, show where there was an assumption that was incorrect, right? They don't even understand well enough to know what was the assumption in that particular measurement. They're like, well, how do you know how far away the moon is? That wasn't part of it. The distance to the moon wasn't part of the computation of the height of the ISS. But that's where they go because they won't even look at it. But in the 5 years since that video is published, 0 flat earthers have addressed it on topic. 0. This is flat Earth.
And Stanley had a lot of good stuff too. Like I remember, you remember Stanley back in the day when he was doing all his observations. Yeah. Yeah, he was really good at that, and he just got bored of it. He's like, "I've done everything I could do."
Yeah. Flat earthers are not interested in truth. They are not interested in engaging on the topic. They only want to deflect to a different topic. When I showed Lanolin the necessary coefficient of refraction for Pike's Peak to match flat Earth, he wanted to talk about a different topic. He wouldn't even address that topic. He's like, "Oh, wet bulb. Like it doesn't matter." Wet bulb, dry bulb, whatever conditions, whatever way you want to measure the conditions, this point, negative 0.88 coefficient of refraction is what was necessary for flat Earth. And it's an impossible condition. He didn't care. So
I saw Third Eye Blind at Pikes Peak. I just wanted to throw that out there.
Right.
Never mind.
Did they disappear from the bottom up when they left?
Yes, they did. They did when they were going over the hill. They did disappear. Bottom up.
I love the name Perfect Fart Storm.
I know, that's what I was saying before. I was saying perfect. I was like, this is a beautiful name. And I said it's not Mark Wahlberg, it's Donnie Wahlberg is the host or the main star.
So good. Perfect Fart Storm. All right. Oh, geez, it's almost 3 hours. Climb ties when you're having fun.
That's right.
Just got in here too. I've never talked to you, MCToon. I've listened to a lot of your stuff, man. It's very entertaining. Can I just say this one thing? When you dissected that one guy oh man, he was, oh my God, where was it? anyways, there was a guy that was completely lying, and he was a con artist, and you had
The Australian
people go down. Yes, that's it. Thank you,
Danny. Sorry, I think it's Danny something.
Yeah, that was awesome, dude. That was awesome.
So yeah, if people
some beach.
Yeah, if people don't know, he was from he was near Melbourne, and there's a big bay. So Melbourne's on kind of the north end of the bay, and he claimed that he was on the south end of the bay, which is quite a distance away. And he sent a picture of the dock from a distance, right?
Seppings.
Denny Seppings, yep. And then he's like, here's a picture that I took from that same dock of Melbourne, where you can see Melbourne, and that doesn't match the globe. And I'm like, he's sending me the stuff. I'm like, there's something fishy about this. And I asked him, I said, well, for the video, could you email me your pictures? He took them on his phone, and he did. And I asked him to do that so that all of the metadata would be included. So I had the GPS data in there. So he wasn't taking it from where he said he was taking it. He was taking it from way closer. So then I had a guy, this is the video here. Had a guy that is in Australia. He was waiting on the exact dock that he was at. And you could tell because the angles to the buildings were there. So we live streamed the actual view to Melbourne. It was amazing.
Yeah, it was. That was really good. And the fact that was great. But the fact that that was like not even the creme. That wasn't even like the cherry. The cherry was when you dissected like the fact that he was selling cars, like fake sports cars or something to people. Like he was a con man.
Yeah.
And I think that's a problem with Flat Earth too, is that you get a lot of people like Mad Mike. He was same type of person that used Flat Earthers to further what they wanted. Yeah.
I like Mad Mike. I don't know.
Yeah,
I don't know.
Yeah, I mean, but did you see what I mean? Like he wasn't a flat earther. He was just using that as like a springboard for what he wanted. Yeah.
I interviewed Mad Mike, and then I interviewed one of his best friends, who's the guy that was making the rockets. I forgot, Waldo Stokes. And Waldo, while I was talking to him, made a point. He's like, there's a lot of people that accuse Mike of not being a flat earther. And Waldo's pissed. He's like, he is. He 100% is. So that I take it as you know, for him saying that. Then after he passed, his publicist said, yes, he wasn't a flat earther. He was doing it for publicity. And Waldo, unbeknownst to him, he didn't know what the publicist said, doubled down on a Facebook post saying, no, he was a flat earther. So, but unfortunately, I don't have that. I didn't screenshot any of what Waldo said. So I don't have any of that.
No, but I mean, and he was close to him. So, okay. So like, I'm coming as like an observer. So if there's going to be stuff that I forgot that like you actually are talking to these people because you have access to them. So I'll say one thing. It was sad. I liked Mad Mike because he was crazy as F, you know, like he
and a stunt man
strap himself to a friggin' he was like the coyote, dude. He's like, I'm going after the Roadrunner.
Yeah, I love stuntmen, and so you know.
Yeah, my dad was a stuntman. Yeah. Back in the day, he was a stuntman too. So they're unique people. They are unique. So I will take back. Maybe I won't put him in with that. The guy that you were talking about before.
Just like back off. Like he could be. But I don't know if it's that clear.
Yeah, but I just wanted to let you know that like I love that. I watched that like 3 times. I've showed other people that too. That just how you dissected that dude. And I just love how you went deep into it though. Like you found out things he did in his past and like, oh, you used to do this and you used to sell this to these people. And
the guy was a total scam. Yeah.
And he was a P worder too. Just messing up, man. That was crazy.
There was that. Well, he's a LDS Mormon, right? And there's a history of that, unfortunately, in that organization. And
Yeah, that's true. Yeah, that's true.
Yeah.
Oh, this is
What's up,
cool, man.
Zynak? How are you, man?
Nice to meet you. This is cool.
Oh, he's muted. Let me unmute him.
Zynak.
What's up, Zynak? How are you?
it's witsit.com.
Yo.
I'm wrapping up pretty soon here, so Zynek, if you're gonna have a lot to say, I'll dip before you get into that.
Oh, you know Xanax then.
Yeah, we've talked before. So
I'll dip before you start talking, okay?
Yeah. But anyway, it's been 3 hours, everybody. Thank you. I don't know if Q Up is still here, but thank you for having me on. It's always fun to stop by the asylum. Apocryphon's Discord server actually used to be called the Asylum, and this is the continuation of it. So thank you everybody. I'm gonna drop out and just go over to the YouTube stream to wrap up there. So everybody on Discord, thanks a lot. We'll see you. All right, well, now it's just you and me. We can talk. Yeah, Zynak, man, he won't stop. And it's an infinite regression talking to him. So anyway, lanolin, derpy. We got right here. You see that? Let's see. Hold on. I don't know yet. Not gonna try it. Anyway, thank you for that. Spherical Earth Propaganda Bureau. We got here. Tad is mad for $2 to stop accosting random people at church, dickhead. Yeah, that, the flatties tend to get kicked out of church because they think that flat Earth is the most important thing of all, right? Which doesn't jive with most churches. That's not their most important thing. So, all right, I gotta go find this one. A member super chat. Here we go. From Cunamat says best entertainment for a Friday morning. Well, thank you very much. This is all it looks like to my program that I wrote. So Brian Peck for $2 says a surveyor said 8 inches per mile squared. Horse hockey. Well, and a surveyor will say that as the first order computation, basically, for horizontal, is a linear drop from a horizontal tangent, right? A 8 inches per mile squared is correct, with 0 refraction being included, which is generally not the case. If you need to make a second order improvement to that, then you would include some amount of consistent refraction, either 7/6 or 4/3 times the radius of the Earth. So it's what you do is when you're doing the math is you just take the radius of the Earth and you multiply it by a number that makes it a little bit larger. So refraction causes the Earth to look a little bit larger, which is closer to flat. The manifold gets bigger. So manifold is a curved surface that looks flat in a very small area, right? You zoom in on something really, really close, and that curve now looks flat. If you've seen the picture of the basketball with the camera zoomed way in, that's a manifold. The curved surface of that basketball looks flat when you zoom all the way in. Normal stuff. Real Arnold says for $5, Mallory enraged PhD Tony was a classic moment in Flat Earth. What is, hold on. What? Northern Rebellion has so many memes. Why are so many grifters attracted to anti-flat Earth? Wow. I'm flattered to be included in there. Flattered. Thank you very much. But the grifter moniker is a little misappropriated, I think. A grifter, I think of a grifter as somebody that generally doesn't actually hold that position. I do know that the Earth is a globe. So, and then we've got Doodle Sound Lab for €2 says DMOC, 100% volume, 0% evidence. What a guy. Yes. And Doodle Sound Lab, is it you? So a couple people sent me a video. Jaren did, Icy Spin did. Hold on. Was that you, Doodle? Is that to you? And you don't know. How would you know? Where's my DM from Jaren? There it is. Okay. Yes, it is Doodle Sound Labs. Jaren sent me your video. I haven't had a chance to even watch it yet, and said sub to him. So you know what? I will take that recommendation and forward it to everybody else, because if Jaren suggests that I sub to somebody, then I feel confident saying to everybody else, sub to Doodle Sound Lab. And if somebody can grab the link, I'll even pin it. I'll pin it, and then everybody can go jump over there quickly. Grifter is a liar for money, says Lucy Willis. Yeah, there it is. From Max. Pin message. And the grifter moniker gets thrown around a lot, so its definition is maybe a little ambiguous. So anyway, that's still up on screen there. Let me get that down. There we go. Anyway, let's see here. We got, is that all right? Is that looking good? It is. We call him Pork Chop. Who do we call Pork Chop? Spin? I don't know. Okay. A week from Monday is the first day the window opens for the Pensacola Beach observation of the sun setting. It's going to do a live stream of the sun setting. I'm going to record on the camera on the P1000 I got right here. Where'd it go? Oh, I moved. It's over there. Over that way. I'm going to record it. I'm going to zoom in with the solar filter. I'm going to record with my live stream with my phone. I'm going to record with the Tuna camera. I'm going to record with the 360 camera. And DMOC has said Damascus Steel says he's going to be there every day starting at 4. Good for him. Amazing. I am going to have also a laser rangefinder, and I'm going to figure out how far away I can get a reliable measurement using it. It's got a pretty solid range, and the key is to get a consistent. So we just know we have a baseline, so we can measure that distance, and without having things that are interfering with it, right? And a beach is a good spot, especially in February, because there's not a lot of people at the beach. It's kind of quiet there, and so there's not a lot of people walking around back and forth. So I'm hoping that I can get that and measure that distance, and then we can test whether or not the Earth is a globe or flat, because then we can use the distance that flat Earth predicts and the distance that the globe predicts to test. So, Doodle Sound Labs is DVids. Well, that makes sense. Just change his name. Awesome. Well, thank you very much to DVids. Okay. All right. I'm gonna get out of here. Hold on though. Remember we got the top left coming. We're gonna get those voting videos sometime. If you're in there, then you should definitely contact me if you're one. Anyway, I'll send messages out too. So all right, hold on. There we go. All right, everybody. We'll see you next week. It's coming. Hold on.
His beard like a thick
Love this one.
His hair overgrown,
Don't cry too hard.
a Wookiee reflection in the dark, all alone. He longs for warm ceilings, for walls to be made, apple flavored comfort from the tractor store trade. In the arms of compassion, hear his fragile song, help insulate the shadows, help him find where he belongs. You can bring Cubby hope, please help him. For only $1 a week.
Don't cry. Don't cry.
Help make sure Cubby never runs out of apple-flavored horse paste from the Tractor Supply store. And maybe even gets a proper ceiling in his damp, moist basement studio of truth.
Promised myself I wouldn't cry.